Welcome everyone for third session, Enterprise Artificial Intelligence. We've been interacting last few sessions. We have various friends attending from Hyderabad and different cities in US and one from Coimbatore, I believe. So this is an enterprise artificial intelligence which encompasses many fields. Data is the foundation. We are focusing on machine learning solutions. Then we are going to focus on deep learning solutions. We also incorporated natural language processing. So the content is very bold and ambitious. So it's really very helpful if you participate in the class and if you focus and collaborate with the team so that you feel comfortable and get clarified and keep moving. So the class will be at a very fast pace, which is optimized for the professionals who have experience, because everyone in our session have very good background, very good experience. So I want to encourage everyone, and I want to appreciate everyone, first of all, coming and participating into this, because this is what the whole world is talking about. As I told you earlier, this is not another skill, it is another discipline of computer science 2.0, and it has a lot of potential to solve many problems. First, before I connect to our friends, let me quickly check if you can hear my voice. DK, Hema, someone can just say if you can hear me. Hema, good?
Yeah.
Okay, excellent. So before we greet our friends, let me just address a few things. So as I mentioning to you, this is not just a dream to wish, oh, this is a good, this is good. No, it is actually moving beyond even my understanding. So every research field, either brain science or astronomy or physics, like hadron collider, particle physics experiments, enterprise customer services, marketing, many fields, IoT, and even blockchain solutions are getting integrated with this enterprise artificial intelligence. So you'll slowly understand there is a reason for that. So I will be sharing few slides. Generally, I repeat few slides, 3 to 4 slides, for a reason. This is one slide I always want to repeat to you throughout the session, because this is the theme. Even in our Facebook group, I put this. You see, you'll see three pies, but in fact, they represent 4 dimensions. One is, as I mentioned earlier, this is a very high demand skill, which is one of the motivating factor for anybody. That is one dimension. Second is, it is a high value solution. You are going to offer high value solution. This is what I want to highlight to everyone. So if you offer high value solution, your return will be good. Your satisfaction is good, because you will be spending the same time. God has given 24 hours to everyone. And in that, you might spend 6 to 8 hours or 10 hours to do some work. But that work If you're adding a lot of value, it is good for you. You'll get returns. Then the third dimension, I listed two, not too complicated and very interesting. It has two parts. It's not very complicated, means you can master it. It's not too complicated. Does it mean it's easy? No. So it's not easy. That is a good for you. Why? It's good for you and us, we all, because people just cannot jump into this. So that is a good. There is a barrier to entry into this. So there is a steep learning curve. So that's
Srini?
where yeah, please.
Srini, this is Kiran. We are getting feedback in between. I thought it was just me, but Nagesh also said that he's also getting some. We can hear you for the most part, but I would say 30% of the time we cannot hear you that clearly.
Really? Let me adjust my microphone. Hema, how do you hear me?
It's clear, Srini.
Clear to you. DK, India?
Yeah, I could hear okay.
Yeah, I can hear you.
Okay, so then it might be my internet connection.
Yeah, just check. There may be situations here, couple of seconds, not if you throw out maybe in 2-3 hours, maybe this hosting solution might give small pause, but that is very negligible. Okay, please check once, Kiran. Thanks for checking with me. So it involves a lot of steep learning curve. So that is where I want to appreciate and encourage you. After a couple of years, you'll sit with me for a coffee and we'll be happily talking to you. So even I focus on few things which add value to myself, to my friends. So that would give you a good journey as you are collaborating with people. So if it is not a good stuff, I will not be discussing with you. So next, it is very interesting. It is truly interesting. So I'm going to share you certain dimensions where you see it is interesting. Because how you see the subject, how you analyze it, how you collaborate, how you communicate, and how you motivate yourself. This is what makes things interesting. It's not that some field is just interesting. Not really. It is different aspects can make it interesting. So I encourage everyone again to collaborate with everyone. Why I highlight that is, you go to the market, you are going to face interviews with the bright minds, bright people. Do not get scared. They want to hire people to add value to their projects. So they just want to filter the right people for their teams. So as they interact with you, as they collaborate with you, they will see your maturity, how you talk about these solutions, how you are bringing your skills onto the table. As you communicate to them, as I mentioned, they see the maturity. That maturity comes is not just by reading the books, or just to practicing few lines. It involves everything. Everything in the sense, I want you to discuss in the class. I want to ask questions in the class. I want you to participate in the Facebook discussions. What you are doing, hey, I'm installing this or I'm doing this, whatever it is, open some communication. In the process, you get connected with our team. So that would give you experience when you go to the interviews. Experience of collaboration. You've been doing it in your workplace, but doing it with a sense of urgency, sense of goal, the sense of learning, and sense of establishing a career in one field really gives you a lot of advantage. So I want to encourage you on that. So this is again one more point is, this is not a short-term course. This is a long-term course. I want everyone to be ready for 3 months to 6 months overall to get into transition into this career. Maybe 2-3 months training, then a little bit of 2-3 months additional research. I started a research lab in this. I'm going to team up with you to take our learning into additional research so that we can bring new use cases from the industry and can present to the team. So I want you to participate. As you present, you really feel good and you share the knowledge to the team, and team appreciate you. And that way you strengthen your understanding. Then when you go and talk to people, trust me, people really appreciate what you learn, what you know. So all this training methodology will consolidate your knowledge, strengthen your understanding, strengthen your insight, and strengthen your ability to communicate to the people so that they are aware that you are a valuable consultant to provide these solutions. So that's briefly about what is the direction we are going. Let me quickly connect to our people. We have a very good agenda. Let me go to this agenda. This is the agenda we have. I'm going to discuss a ML process and the data architecture. We've been talking unified Lambda architecture. I will quickly touch that as well. And I'll also talk a little bit background of Scala and Python. You started doing Scala, and after a few weeks, you'll be doing Python, PySpark for deep learning. So you need to understand how these languages have evolved and why they became so popular in this field. I need to share certain background. Then this is the center. The second one is our central discussion today, the clustering and anomaly detection. So we are going to focus on one particular algorithm in the machine learning, which is used to solve many problems. This is the beauty of machine learning. You might have one algorithm or one set of problem, clustering algorithm or anomaly detection is used for anomaly detection as well, but it is a clustering problem. You take that clustering problem, you can apply to solve many use cases in the industry. That is the beauty. So that is the central we'll be working on. And we'll have some break. Then I'll further discuss with you Spark and Spark SQL and introduce some Cloudera environment so that we'll be ready for tomorrow for additional practice, where our friend Harun is going to support us with additional examples. Okay, excellent. We have a lot many friends and very interesting people also joined today. So let me connect with everyone. Very interesting. I said with whom I worked before. I think Nagesh also joined. Great. I'm going to talk to him. Okay. Here quickly, I have Akhil. Akhil, who worked at Ford. Akhil, how are you today? And you welcome to this session, which will definitely complement your already existing skills. You want to greet our friends? Say hi to everyone. You're on mute. If you want, I can unmute you. Okay, yeah. Okay, we can't hear you. Next, I go to DK because I had about you. DK, you want to greet our friends? Get to know. DK, you're on mute. I'll unmute you.
Hi, everyone. Good morning. Looking forward for the session and looking forward to collaborate with you all.
Wonderful. Welcome. Harish Bokre, working Apple and colleague. Hey, Harish, how are you? You want to greet our friends?
Hey, Shuni. Hello, team. Good morning.
Excellent. We have Kishore Nand, Infosys, Bangalore. Hey, Kishore, how are you? You want to greet our friends?
Hi, Srini. I'm good. Okay. Good evening to everyone in India and good morning to everyone in US. Looking forward to the session. Thank you.
Excellent. Very good. Hema, how are you today? You want to greet our friends?
I'm good, Srini. Hi, all. Good morning.
Excellent. Lakshmi from India. Lakshmi, how are you today? Do you want to greet our friends? You are on mute. Okay.
Hi, Srini. Good morning, everyone.
Excellent. Welcome. We have Mukesh. Mukesh wanted to do big. He has a huge data warehousing background. Wanted to do big data. Attended most of the sessions. Have some break, but he want to come back and to fully focus on this artificial intelligence. Welcome, Mukesh. Hey, Mukesh, how are you? You want to greet our friends?
Hey, Srini. Hi, all. Good to meet you all. Good to see you back, Srini.
Excellent, excellent, Mukesh. Encourage everyone. You all have very good background. Now with this subject, we are collaborating. I'm pretty confident every one of us built excellent career in this. We have Narayana from India. Narayana, you want to greet our friends? How are you?
Hi, Srini. Hi, everyone. Good morning to US and good evening to India. I'm looking forward for the current section.
Okay, excellent, man. Raja, master's finished. He's doing job. Raja, welcome. You want to greet our friends?
Hi Srini, I'm doing well. Hello everyone. Thank you.
Excellent, guys. I spent 10 to 15 minutes for this, though it's very valuable to know people, and the more you know, it's going to be more interesting, especially when you're working on something like this, a common platform. I know everyone is good at the people. You already collaborating with a lot of people, but this is we're collaborating with a purpose, with one particular agenda. So I want you to know everyone. So Siva, my friend from Apple, he needs to go. Hey Siva, how are you, man? You want to greet your friends?
Good morning. I'm doing good. Hello, everyone.
Excellent, excellent. I'm so excited to introduce Nagesh and Leela. Nagesh, hey, Nagesh is very interesting personality. Welcome you, Nagesh. We had a great discussion in our classes. He is very critical to analyze things. You put wonderful questions. We had a great collaboration, and he presented many topics in big data. He is now working as an architect. Hey, Nagesh, can you give your background and greet our friends here as you're first time joining here? You're on mute, I believe. Nagesh, we can't hear you. Let me quickly go to Kiran. Kiran, you want to greet our friends? You're on also mute. Okay, let me introduce Leela, a new friend joining us from Milwaukee. Welcome, Leela. She has seen our video recordings and she wants to continue from this batch. Leela, welcome. You want to greet our friends? You want to give briefly your background?
Hi all. I work for Wipro Technologies and I work here for Best Buy. So I have like 8+ years of experience and I wanted to switch my career. So I got Srini's contact through Akil and I'm interested to join this session.
Wonderful. Welcome, Leela.
Thank
you. Nagesh, you there?
Hello.
Yeah, Nagesh.
Are you able to hear? Yeah.
Welcome.
Sorry.
Welcome back.
Yeah, I was trying my wireless. I mean, the card was not good.
Excellent. You have
thank you,
many
Srini.
people from here. Welcome back. And
yeah, thank you, Srini. I'm glad to hear your voice. I was trying for last 2 weeks, but I was not getting. I was wrapping up my project. So I was working with a Bank of America as an architect. So I had to go through a lot of wrapping up the project, and the last minute it was going in production and all that. So I couldn't join you last 2 weeks. I missed you. So today I thought at every cost I should join you. So this is a good time because I'm in between projects, so I can focus on this.
Wonderful. You want to communicate? You're already working in big data as architect, because if you say architect, they might be thinking some other architect.
No. This is a big data architect. I was working in the platform services and strategic services and application side, performance tuning. It was an interesting journey. Thank you, Srini, for your opportunity. I owe you for this. So I really enjoyed because I was working with the different clients because in the Bank of America, there is a one group called Hadoop as a service. What they have is they have a 1,000 nodes in a cluster. It is a cloud data environment. They have you name it, all the products, they do that. One is like a Hive, Spark SQL, Spark Streaming, Kafka, and HBase, other things. So the one of the duties is I have to support the production issues. So in sense, when the production, if there is an issue with the Spark, what went wrong, and as with your with your motivation, I could do a lot of training to the existing clients because they were not aware of the Spark side and Hadoop side. And as you said many times, you told me in the Hadoop world, people don't know much about Spark. So when I went there, I explained I used to do every week training to the interested groups because there were 3 groups. One is like data governance and other things. So I was teaching all the memory architecture, yarn, and all that right from that. So there are, yeah.
Yeah, we are looking forward to collaborate with you. We have wonderful people from both, India and here. They are looking to collaborate with me and my associates, and you have a great experience. You collaborated with me on trainings and you took training. Then you contributed to the training. Then you contribute to a client at a high-end client. You saw the issues, you have seen the big clusters, so that experience is very good. So sharing that to our friends really help them, motivate them. Hearing that from multiple people will consolidate their motivation, their understanding. So let's work complementary. I will equip you on this enterprise artificial intelligence. We scaled up very quickly on machine learning, deep learning, and natural language processing. Long time back, you told this is one field is interesting to you. I'm pretty sure you come out from this routine engineering task to now more into science and solutions. So that way you will see the lot of value you're going to add, but at the same time, your experience is going to be very valuable. So looking forward for you, Nagesh.
Thank you.
Yeah, excellent. So quickly, Akhil and Hari.
Yeah, hi, good morning, everyone. I'm Akhil. I'm a student for Srini from few years. I'm enjoying working with Srini. I'm learning so many things from this session. Thank you.
Tell about you, man, not about me. You worked at Ford?
Yes. I worked at Ford as a big data engineer.
Excellent. So he worked on connected car project, which is a very valuable in, I think, coupling with this artificial intelligence knowledge, it will be great. Basavaya, you want to greet others before I jump into the agenda? Basavaya from India. Okay, when you get time, greet our friends, Basavaya.
Yes, Srini. Good morning and good evening all. I am Basavaya from Tech Mahindra, Hyderabad. I am into automation and performance testing engineering. So shortly, I am moving to Philippines for a work assignment from Tech Mahindra.
Okay, Hari. I don't know who is this Hari. Hari, sorry, I missed your name. Is this Hari from Coimbatore?
Yes, Hari from Coimbatore.
Hari Babu.
Good morning, everyone in the US and good evening to all in India. It's nice to collaborate with you all and looking forward to the session.
Excellent. Let's move forward, guys. Thanks for knowing everyone. Let's move forward. This is the agenda. As I mentioned, see, ML has a process, machine learning has a process, but most of the time that process will be very much the same for deep learning, and natural language processing also. So let's understand, this is the process. You have seen this slide before. So you need to get the data, you need to prepare the data, whatever the, sometimes it's some cleanup, or sometimes you'll have to split some strings so that it is prepared for machine learning, deep learning. So these two steps deals with basic data and basic programming. So when you're dealing with this data, you need to be in a position to do programming, right? So for programming, people use here in the big data environments, not any general Java, general Python, general Scala, no. The programs that are compatible to cluster environment. Our friend Nagesh has mentioned he's almost working with 1,000 node clusters. So we need technologies that work on parallel environments. So that is where historically we have MapReduce that is getting replaced at many places with a Spark, a de facto standard, a cluster computing platform. If someone asks you what is Spark, you can say Spark is a cluster computing platform. Cluster computing. This is for computation, not for storage. Computation. Whenever there is a computation involved, you will have programming. Not too lengthy programming. Big data and artificial intelligence doesn't involve a lot of programming. It involves very less compared to general programming. Why? Because in general applications, you try to capture the business logic in the program. But in the big data world and artificial intelligence world, the logic is there in the data. So you write the program to capture the logic that is hidden in the data. The intelligence is there in the data. The unknown logic is there in the data. So you cannot code the unknown logic. Historically, people have coded intelligence, coding the logic. They put this logic in the code and think that they built a smart machine or intelligent machine. But intelligence is there in the data. But still, you need to write some program to capture that intelligence. But so, trust me, this is not a program intensive. But does it mean it's easy? No. It's definitely challenges. There will be a lot of challenges. Even you may have more challenges than even other systems you have made. But interestingly, there is a lot of help is available. Most of these systems are open source systems. They're open source communities. The code will be available everywhere. The Stack Exchange, Stack Overflow, or other communities. You get a lot of help. You don't need to remember a lot to code. First, you please get prepared to read the code. Am I comfortable to read the code and understand the code? Then you can focus on writing the code. Many times you can do copy and paste. There's nothing wrong. The idea is not to remembering the syntax, etc. The idea is to think hard, think about the problem, think about the process, connect with people, and speak the language they are speaking. Understand what they are talking. So you need to be familiar to get the data and clean the data at appropriate place. Some people, oh, I want to get the data, let me go to OLTP system, customer systems, and get it. No. You need to understand the landscape, how the data flows. So you need to collaborate with the right people. If you had worked with a company like Apple, it's very interesting. There are thousands of systems, hundreds of people maintaining it, and nobody tell you whom to meet, etc. You're on your own to figure out. Hema, You want to comment anything, Harish, Bokre? You collaborate with hundreds of teams. Emma, how do you share your experience in Apple, working with people, working with systems, where nobody guide you whom to go and talk, whom to go. Sometimes you don't even know. Even your boss also does not know whom to talk, right? Sometimes.
It's all about collaboration with different teams, different players.
So many teams. You're right. So you need to, that is where understand the right teams, or rather right landscape, so that your journey is comfortable. The third step is so these first and two steps involves the programming and data, how you handle it. So this is where comes, you need to, for machine learning, we are going to use Scala and Spark. So these terms is valid. Still, you need to focus on RDD. So you will be in a position, rather you will be doing transformations on these RDDs. You'll be doing some actions. If the data has schema built into it, you can directly build a data frames. See, just 4 words to start. RDDs, transformations on RDDs. DK, I think you are getting familiar with this. RDDs, transformation on the RDDs, and actions on RDDs. The schema is built into the data. Schema means you know the structure of the data, like either a JSON file or XML file or some other files where even schema is built into it. You can build data frame directly. You can think them as a table almost. I highlighted one more point very clearly. In this big data world, your data will not be available in tables. Here and there, you see them as tables. But first, let me tell you, your data is in the form of files, CSV files, JSON files, Parquet files, some ORC files, in Hadoop, or in S3, or your data is in Hive. It sounds like they are tables, Hive tables, but it's a Hive data store. The data can be available in MongoDB to read and write. Data can be available in the Cassandra, Elasticsearch, even in fact 20 other sources. Spark is going to support many NoSQL databases.
Srini,
yeah.
I think the recording is not on yet. Is it on? Okay, recording.
Yeah.
Are we hearing some keystrokes? Somebody, I don't know. Can we?
Yeah, so there is some keystrokes being heard every time you speak. I'm not sure.
Let's understand. First is recording is on, right?
Yeah, recording is on. Looks like.
Recording is on. What is exactly keystroke? Is this laptop?
Some kind of echo. I don't know. It's not called echo, but it's
Srini,
kind of.
Srini, I think Kiran has put out chat that it was him.
Yeah, I was taking notes, Srini, when you were talking, so it might be me. I thought I was on mute. I don't know why is it still picking it up if I am on mute.
No. Okay, that's great. So let me mute all. So,
could you?
Yeah, okay. I put everyone on mute. Whoever want to speak can unmute and talk. Okay, let's try, DK. Thanks for feedback. That's where I truly appreciate that. Anyone you see a small issue, please jump into it and don't hesitate to communicate. Thanks, DK. Okay. The data can be, that's why we say the data store. So in our classes, slowly, step by step, you'll be getting comfortable with pulling these data. You'll see a pattern. Once you're able to access S3, Hadoop, Cassandra, and few resources, you will be comfortable. Oh, okay, there is a pattern, there is a connectors you need to use, then you need to pull it. But ultimately they are RDDs. Transformations are involved, actions are involved. There is a schema, data frames are involved. Excellent. Keep that 4 words always in your mind. Just 4 words. You can build a story with these 4 words. Then you see, train the model. There are 3 other steps. I'll talk about this after some time. Keep this slide. I'll be even bringing this slide again. Okay, I don't want to spend much time on this. You already know, but I want to highlight one point here. Okay, quickly, first of all, this is data ingestion. People store the data in the batch. People also can stream the data. Don't worry, there are a lot of tools to inject the data. They are very much automated scripts. There is no much intelligence is there to do the storage. A lot of products doing, because there is nothing, no computation is involved. It's just regular tools. So this is where your role starts mostly. After, when there is a storage, you should be in a position to write the programs to pull the data and write it to Cassandra, write it to Elasticsearch, write it to even Hadoop itself, or write it to Kafka. Please observe, literally you are doing a simple batch programs and doing some transformations and writing somewhere. That is what needed, because you are that is what needed. But that is not end of the world, because this is just a preparation for the next steps. You are moving the data for serving layer. You may be moving the data, streaming.
Sorry.
Please.
I still can hear that noise in between. It's very disturbing.
Oh, do you see the noise?
I think that's your mouse click, Srini. I might be wrong. I am also hearing that. That's probably Srini's mouse click. Mine was like continuous typing. But when you said you can still hear it, I wasn't typing at that time.
Okay, see his mouse making.
Yeah, I didn't. I mean, maybe it's not typing. It's something else. I don't know. Yeah.
I'm surprised. Let's observe. Okay. Any ghost joined our meeting? Okay. Let's observe. Okay. So, but this is only a beginning of the data. Please observe this. This architecture you have observed. There is a data ingestion platform, Kafka. Everything that happens in the company can be injected to this. This is the batch. In this picture, the diagram is reversed. The storage can be anywhere, either S3 or Hadoop, for that matter, any system your company wants. Because nowadays, most of the NoSQL databases are, cluster friendly. Cluster friendly means fully scalable. With Hadoop I/O. So that's why I encourage you, when you're applying for jobs or when you're pursuing this career, project yourself as a big data engineer. For that matter, it is now a machine learning engineer or artificial intelligence engineer. Don't say Hadoop developer. Please. Don't say Hadoop developer. You want to say, as you like developer word, you say I'm a Spark developer. Don't say Hadoop developer.
Sorry, Srini, there's a lot of disturbance again.
I'm not using any clicks. Let me see what is happening. Is that the same for everyone? Emma, how is it?
Yes, Srini, we are all hearing that noise.
We are all hearing that.
Really?
Yeah, so...
What type of noise you are hearing?
Some click sounds. You're not getting it?
It's like somebody's tapping something or clicking something.
You put everybody on mute, right?
Yeah, I did. Let me see. I put everyone on mute. Only I'm speaking. I don't have any background noise. Okay. Let me see quickly.
Is it your speaker, Srini?
I'm not a speaker. I'm using my earpods.
Okay.
I'll see for another 5 minutes. Otherwise, I'll dial in through my phone and see if that makes any difference. I'm using my computer audio. DK, just please monitor again. Another 5 minutes. I'll change it to the phone. Okay. So here, this is the batch. This is the streaming. But here you'll be writing some programs. Here you'll be writing some programs. For what? To interact with a serving layer. So you may be writing into Cassandra, you may be writing to Sech, you may be writing to S3. But this is where you please observe the machine learning. So your machine learning systems are going to take data from the serving layer. Of course, in advanced systems, even your machine learning can directly deal with the data from streaming data. Sometimes this data store itself may be in Hadoop itself. But that does not mean you're accessing immutable data. You may be accessing some view that you have built. Let's go back here. You see here? DK? You compute with Scala and Spark. You compute means you're writing an output. You can call it as a view, output view. That view, you may be writing to this Cassandra, etc. in serving layer, or sometimes some people write to Hadoop itself. So in that case, that file, that part of the file, those files in Hadoop, it will act as a serving layer. So that's where you need to be clear from where you are reading. You need to collaborate with people to understand where you are reading. Okay. DK, how is the sound again? No? Before I switch to this phone. You're on mute, DK.
Still there.
Still there. We were not getting this last couple of sessions. I'm not sure what the trick is. It's not like it's very unbearable or anything, but we are still getting the disturbance.
Okay. The slides are no issues, right? Only audio, right?
Yeah, correct.
Okay, give me 1 second. Let me switch to the phone. Hi, everyone. Can you hear me? Emma?
Yes, Srini, we can hear you.
Okay, let's
Yes.
see. I connected with my phone. DK, please monitor and let me know in case if there is a change. Okay, let me move forward. So that is where this data, you need to get the data and handle this data. So before you run some model, now let me come to this part. So once you have the data, you need to train a model for the data. So when you're doing a training, you need to understand what problem you are trying to solve. Am I solving a clustering problem? Am I solving a recommendation problem or personalization problem? Or am I solving a classification problem where a yes or no decision, a loan is accepted or denied? Or am I solving a problem where certain prediction is involved? Prediction means not prediction yes or no, some value, predicting the stock price value, predicting the home values, predicting certain a quantity. So you're forecasting, Because here there is no forecasting here. Here you are clustering, but of course the clustering may be used to find the anomalies, outliers. Those are not predicting the values, rather identifying or predicting the outliers. So you need to understand what type of problem you are solving. So that's where this model comes into the picture. You train the model. If you train the model on the historical data, when you're training, that is where the machine is learning. Please understand. Machine is learning means machine is creating a base model, a base understanding, a baseline. It's creating a baseline in the system, the machine learning system you are. But you want to test that model. You want to see how accurate it is. Is it 60% accurate? It's okay. Even if it is 50%, it is okay. Because the learning doesn't stop. The learning continues on the new data. So, but what is that? Hey, it is, sometimes it may not be percentage, but you want to test to get the feel. Hey, okay, yeah, this is working. So you want to use this model on some test data where you know its outcomes already. So you test it. Oh, seems to be working good. Seems to be working good. You get fairly understand. Or sometimes you may quantify, hey, this is doing 60% is good, 60% is good, 70% is good. Then you need to go to the last step. You need to improve this system. So certain hyperparameters will be there. How many clusters you want to do? How much learning? Not how much learning. How many, mainly in the clustering program, how many clusters you want to do? In the case of recommendation problems, there will be certain other hyperparameters will be there. So you'll be getting to know. Today I'll be introducing to you one particular model. So these are the 5 steps that are needed to build a machine learning a solution. But again, question remains, what for I am building this? What is the necessity of this model? That's a very interesting question. You're going to take this machine learning model that you built and going to apply on the new data that is coming. The new data that is coming. When you apply, you will know whether this new data is outlier or not, whether this new data is an anomaly or not, whether there is an issue with that coming data or not. That's how you'll be applying. So you'll be applying it and finding the outcomes. That is all good. So it is, you are applying for a use. Is that correct, DK? Nagesh? Is that correct? You have built a system and started applying on the data. So it's in use. But that doesn't stop there. As the new data is coming, that new data will be added to the historical data. Today's new data becomes, tomorrow it will be yesterday's data. This is the historical data. Today's event is tomorrow's history. So your machine can learn from that new data also. So that way it will be improving its outcome capacity. That is what the machine learning is all about. The central process. So you'll get to know class by class how to do this. It cannot be visualized everything in one class, but you get this at least gives you a fairly good sense. That is what my thought process was. DK, any question before I start going to this particular anomaly detection, one particular model I'm going to take? Hema, DK, how is the voice and any questions?
Very good.
Okay. Okay. Let's get into it. Anomaly detection. See, quickly, anomaly detection is you are identifying the items or events or observations which do not conform to an expected pattern. That's the expected pattern is from historical data, you can identify certain patterns. Suppose I have a historical data, I train a model, I get some clusters. So those are the patterns I have. But we want to, on the new data, we can identify items or events or observations that do not conform. If some data is happening, if they're falling into these clusters, it means they are conformed to your expectation. If something is abnormal, anomaly, that is what we are going to identify. So it is used at many places in industry, in network security. People will be accessing your computer networks remotely. So as they access, a lot of employees fall into certain patterns. For a period of time, your system knows that these people, Hema or Harish or DK or different employees, all the patterns are like this. They'll be, it may be location, it may be IP addresses, it may be a combination of many things. Combination of many things. How many times you are accessing, what systems they are trying to access. There is a pattern involved every day, every week. So any new access that come, like cybersecurity hack, when they're coming, these systems, the models that you already built, can take that input and throw it as an outlier. Or if it could not, at least you learn from next day. Oh, there is one attack, our system could not find it. But if somebody entered it, at least let's close this and let us learn from that lesson. Something like that. Customer security, your credit card, your banking transactions, your online access. You might have seen you're trying to access your Google or you're trying to access your Facebook, Twitter from different places and different timings. They will send you an email. Hey, I think there is some suspicious login. A new login came from this computer, a new login came from a different location, or somehow we felt suspicious. They will send a mail. Is that you? If it is you, please ignore, something like that. Customer security. IoT and manufacturing. In industries, a lot of machines, even the aeroplanes, lifts, different machines. They need maintenance. If they shut down, lot of delays will be there in the service. It affects the productivity. What if we can identify the issues in advance, can predict it needs a maintenance? How can you do that? Some historical data of this manufacturing IoT data, if you can, there are sensors, you don't have to worry. There are other departments which make these sensors available, make the data available into Hadoop, stream it, and make it available into serving layer. That is where you'll be applying the machine learning. And you can run on the historical data. Based on the historical data, you can build a model, clustering model. I'm talking about a clustering model here today. So these clustering models, then based on these models, on the new data that is coming, if you start applying, you know the machine is running slow, or its vibrations are like this, or these parameters of that machine is different. So you can trigger, hey, these are outliers, so that might need a predictive maintenance. That is a big thing. IT infrastructure monitoring, last one. This is also very, very important. Hema, Harish, DK, you guys all seen big systems in SAP, PeopleSoft and web services, and everyone for that matter. So there are now in the big data world, there are thousands of machines. Even in the web services, there are thousands of machines. So if you take one example in the CERN, where they do nuclear physics, where they do particle physics research, with $1 billion of funding, they have thousands of databases, data stores. So they want to know each instance, how it is performing. Is it slow? Or when people started accessing, how it is? Or when web service calls are going, how the response times, etc. All these things they capture. That is the metadata of the whole IT infrastructure. Nowadays, it is becoming very popular. Microservices, even how those microservices are being performed and monitored. So all this involves a lot of data. You can cluster them. You can find outliers so that you can identify the issues with those services, infrastructure, servers, how they respond. So many more areas you might come across in your company are clustering customers. So all these places, this is used, and I'll be interacting with people, rather collaborating with people and bringing new use cases also. But interestingly, clustering will solve this particular problem, that is anomaly detection. So let's get into it practically, how we are going to do. I'm going to show how we are going to do it. So what is the strategy we are going to use? This I discussed on the orientation session briefly. Let's connect back. DK, can you just can you recall what was the strategy you want to apply for the outlier detection from this diagram? Can you recall, if you can you?
Yeah, I think you need to identify the number of groups that you want to make. I think decide on that first, and randomly, I think choose some point in each group. Right, and then I think you kind of in many dimensional you calculate you know the distance with other points, and then regroup them again, and you do that iteratively many times to come to a final grouping.
Nice. That is fairly good. So the underlying algorithm is that the clustering Let's go a little bit high level. That's a very good points you have given, DK. You go a little bit high level, we need clusters, first thing. So below that level is what happens behind the scene. To make it clusters, it uses a clustering algorithm where you may have different points. You don't know what clusters they belong. You are giving that to a machine. That machine uses the libraries. That libraries have that internal code which does that iterations. Randomly it chooses, say you say 5 groups, randomly it chooses five centroids, then try to make 5 groups. Then the groups, based on the groups, the centroids will be moving again. Then again groups will be formed. The groups will be refined, redefined. Then again the centroid move. That iterations, whatever we can mention, that happens in the library itself. Interestingly, they have coded in those libraries and given us to next level. So when you run a model, all this is internally computationally given. But for you, it is a cluster. A cluster model is given to you. When you run a couple of lines, the models will be created. I will show you. So since you are in applied machine learning, you start from there. Okay, I made clusters, 4 or 5 clusters. Number 1, based on the data. I have this cluster, this cluster, this cluster. I have 4 clusters here. I'll see whether 4 clusters is good or 3 clusters is good. So let us start with 4 clusters or 5 clusters. Then, what is the maximum distance? This is the maximum distance for it. This is the maximum distance for it. This is the maximum distance. And this is the maximum distance. Now, how you know something is a outlier? Suppose I have here. Of course, this may be outlier to this, or this may be part of this. You need to use some criteria, right? You need to use some criteria. Okay, this point, the simplest criteria they use is, okay, this is the maximum distance, even though for this is the maximum distance. You can use that maximum distance. You can apply. You can apply even to the other clusters. Or some people take the maximum distance of that cluster itself. But we'll see as we do it. You have an options. You will see. But let us find the threshold. Let us say this is the threshold. Let us apply. Any new points coming, those new points fall into this cluster, this cluster, this cluster, this cluster. They may fall into it. Or they may be an outlier. To know the outlier, we will use the threshold. So I'll open the discussion after some time, but let us see, because it has multiple steps. But this is a high-level strategy. I'm going to get the data. I'm going to have a training data. I'll have a testing data. I'll have two sets of data. One is training data. I'll train the model. Then I'll try to identify how many clusters are there, how many centroids are there. I'll compute I'll find the maximum distance threshold. Then I'm going to use the test data and see if I can find the outliers. The last step is I will improve the hyperparameters. Whether I want four clusters or 5 clusters, what is the basis for it? So this example will give you the methodology, approach, certain strings, how I'm manipulating, how I'm preparing it. Give you a sense. It doesn't make you masters. Try to read the code as I write and get slowly good hold of it. Let us complete that cycle. That is the agenda I'm getting into. Any question on this at this time? Kiran? Does that sound good? Okay, let me share my desktop. Earlier I shared just that particular. I'm going to get into okay. I think some voice disturbance. Let me mute some people. I think it is not my voice. Okay. Hema and DK, Kiran, how we are doing on the voice? You're on mute. Kiran? Hema?
Srini, it's good now.
Okay. Excellent. I logged into this cloud. I hope everyone has access. I'm still going to introduce to you even other environments by end of this session. So from tomorrow onwards, you'll be even doing on that. Let's get into this now. Let me go to here. Okay. One of the thing is you will be importing certain libraries to solve these problems. Okay. Add a cell above. See here, I already told you, you have this object. I'm running it. SC object is available. So which is a Spark context. Few objects are available on this cloud. But to do additional problems in the machine learning, you'll be using additional libraries. So those libraries are Spark libraries. Since my problem, Hema, DK, Nagesh, Kiran, the problem I'm trying to solve is a clustering solution, anomaly section. So I'll be importing this is a template. So you can copy and paste. No much intelligence is. You are importing a Spark machine learning library, a clustering library, which has a objects called k-means objects and k-means model objects. You'll be also importing a library called linear algebra vectors. Scala gives some vectors like arrays, lists, and vectors, but some improved vectors are used in the machine, the linear algebra vectors. The vectors object is used, even vector object is used. Okay, you just improve this. So I'm running this. So when you run it, they'll be imported. So what I will be doing is I'll be taking certain data and doing a preparation of the data. To prep the data preparation, you need some fundamentals. So let me work on 5-10 minutes on fundamentals. Look here. Let me use another cell so that when I write, it will be easier to see that the animation type. DK, you already know, right? This an array. If there is an array, you can declare an array and see how you can take each element of an array. DK, this an array has indexes, right? This is 0 element, this is first element, this is second element, like that. So let me print 2 elements of that. So I'm going to print, I'm printing from this A data 0 indexing is a first element. A data 1 is a second element. A data, see here, it printed. Sometimes it print above it. So this is a data type
display. This is 1. 1 is this one. Leela, are you following me? This is 1.
Yeah,
This
yes.
is 3.
Okay.
So this is 0th element. Like this, you can pull the data from an array. That's good. So let me introduce you, or let me say, I want to sum these elements of an array. See here, A data has a sum. So I'm summing this. See here, 16. So 1 plus 3 plus 5 plus 7, 16. So like that, when you're handling an array, when you're handling its, what you call it, you want to know each element, you want to find out the sum. All these are methods that are built into the array. So I shared some material on the Facebook group. Get into that material and go to arrays, go to strings, go to integers, what are the different operations they are doing. Do it selectively based on this class as I'm doing it. Use some additional facts. Okay, this next you see, I want to introduce you, maybe Arun might have introduced this. At least I want to give some sense so that will help me to write a bigger program. See, I have a T data here. Hema, what is this? I didn't say array or list. I just have the T data. I put in the bracket.
Abhi?
What is this? Let me mute.
Bathroom.
Okay. So,
It's an array.
Hema.
Double data type.
Yeah, if you see here, I just put in bracket of just the 3 values. This is not a list. This is not an array, everyone. This is called tuple. Tuple. So a tuple can be 2 tuple. If there are 2 elements, it is called 2 tuple. If there are 3 elements, it's a 3 tuple. It is 5 elements, 5 tuple. It is n element, n tuple. So how you get the data? Println T data. You can't use the indexes like this. You can't use indexes like this. Do not take parameters. For tuple, you'll use a different syntax. Dot underscore 1. If you say, see Hema, you get the first element, 1, 0. Do you see that? If I have put a 2, I'll be getting the second element, 2. Or if I put, 3, I'll be getting this. That is how you spit out the tuple. Arun will be giving you more insight about them, but let me put a foundation for my program. So it's a very simple structure, just like that. Yeah, anyone?
Srini, this is Sairam.
Yeah, Sairam, welcome.
Thank you. And this one you said that, I know this is tuple, but why is it showing double, double, double? What does it mean?
This is still this data structure. This one
is
a
okay.
T data.
Yeah.
T data is a tuple of double. This is
tuple of double.
1.0 is double. 2.0 is double. What is its type? Suppose I given 1, 0. It might have given as a int, or even p. Now let me run this. No, I'm not printing anything. Sarah, this is it. T data is a tuple of integer, double, whose value is 1,
that one.
2, 3. But that's a good question.
But
now,
in the meaning of tuple is, if you have data with different data types, like multiple data types, that's called tuple, right? It could be like combination of string, integer.
Yeah, anything you put in the bracket, it becomes a tuple. So see, an element in a bracket. That's it.
Oh, so n elements. So all those can be of same data type as well. I thought
No, they can be same data type. They can be even any data.
Oh, okay. I thought the tuple is like it should have like a different data types.
Oh, no, need not.
Okay.
Excellent. Good question, Sarah. I'm putting this here. Okay. Let me go and introduce you another object. He is called vector. Please bear with me. Just a simple foundations. Here, what is this? Hema? Here I have a value A. Let me say A data, or let me say A data. What it is not there. So let me say B data. Emma, please see. I used vectors from this library.
It's like a list.
See, it is with. It looks like a list. It appears like a list, but its data type is this. Please see.
Vector.
So it is a vector, linear language, linear algebra vector. V data. V data is a vector. So in the machine learning, vectors are very much used. The vector is nothing but a point. Please observe, Hema. X like x1, y1. Like if you have a coordinates, x1, y1 is a two-dimensional point, right, Hema?
Yes.
X1, y1, g1 is a three-dimensional point. Some other p1 is a four-dimensional point. Of course, we can't visually see that point because human eyes, we live in three-dimensional world. But for mathematics, for computers, it's a four-dimensional. P2 is another dimensional world, dimensional point. Come on, I put you on mute, but you can unmute and talk. Do you see this? 1, 2, 3, 4. So in machine learning, we use a lot of vectors. That's why this data structure is very important. So I have a point. I have 2 points. So A is 1 point, Leela. A is a point, just like a mathematical point. It's 3 are vector, okay? A vector. Vector means nothing but a point. A is a vector. The x1, y1, z1. x2, B is a point, x2, y2, g2. Why I'm giving you all these things? Because in the clustering, you deal with points. You deal with vectors. You need to group those into clusters where you are dealing with this grouping of points. Even you get told, or everyone knows, we are going to compute distances. So distance between 2 points, all those things. So you need to brush up those fundamentals. And with this learning, you can further brush up in the week. And as we do in the class, you'll be more comfortable. But just as we are having a foundation, please focus very much. Simple 2 points, Kiran. Look here. I am introducing you one small operation. See here, where I am zipping that, zip data. Let me say zip data. Let me say zip data. What I'm doing is, you remember, anyone remember this formula between distance between 2 points, x1, y1? Emma? You are from mathematics background, right? Yeah, I know you're MCA, but I'm pretty sure. What is the distance between these 2 points? Emma, question to you. You're on mute.
Root of x2 minus x1.
Excellent. Square root of x1 minus x1 minus x2 whole square
Plus
Where is it? Well, let me. Whole square plus y1 minus y2 whole square. This is the distance between. So see how you can compute with few operations. See, look here. See G data. So see here x1 minus x2. This is x1, this is x2. This is y1, y2. This is G1, G2. So there is an operation that can group these two. So what is that is, you take A, you convert it to an array, convert it to an array and zip it with B, like our zip for our suitcase. What zip does this? If you zip these two, these two will be together, these two will be together, these two will be together. Say zip B, but you can zip only when you convert it to an array. So I'm converting A to an array. A is a vector to an array. Zip B to an array. Okay. Then see what happens. Sairam, please bear with me. Little bit small math. What is that? A to an array dot zip B to array. Okay. Please observe. Need a lot of observation for another at least 15-20 minutes, guys. Please observe. Leela, look here. A is a vector or a point. B is a vector. When you zip these 2 points, what happens? You see, this is x1, x2. See, they became together as a tuple. Yeah.
Yeah.
2028 became a tuple. Please observe. 3039 became a tuple. You see.
Yeah.
But all are put into an array. Please observe. All are grouped. It is a kind of x1, x2, y1, y2, g1, g2 together. Again, for the why this array is still, it holds that point, holds those 2 points. Now please see, we are heading to Hema's formula. Now we want to know the distance. What you are going to do? You need to find the difference of this and square it, difference of this and square it, difference of this and square it, then sum it. Hema, is that correct? Hema, am I confusing? You're on mute, Hema.
Yeah, we are clear.
Okay, excellent. So let me go here. So I am now using my map operations. You know, I'm going to another just writing value. G data. I'm taking now G data. I'm mapping. Take each element. Each element means take one element, and you repeat it for everyone. Each element. If you want to say, I can say E for element. Each element of this Hema, this is tuple, right?
Yes,
this is tuple. How I get element dot underscore 1, right?
Yes.
This one minus
element of second element.
Element of the second one. Since I want it to have a square, I just need to multiply with the repeat, right? Okay, let me run this. What happened? Element at one. Where is the issue? G data is given. Let's say G1 data. G data. Not found value G data.
Yeah,
G
capital
data.
D. It has to be capital D in Z data, line 8.
Okay, very good, man. My friend. You always help me. You help me in Apple, you help me here. Very good. Excellent. Harish, what happened here? So look here, still that is an array because you're holding that point, holding the interaction between those two. So look here, here it is group this one. Now this time it found the square of this. So it found x1 minus x2 whole square. This is y1 minus y2 whole square. This is g1 minus g2 whole square. Emma, next thing is you need to sum it and square root it. That's it, right? Right.
Yes.
Okay, let me do that. So I can directly get into this. So I am going here. It's the square root, math.square root is the general math library of G1 data. G1 D caps again.
Why did it get so many decimals?
So you have to do sum of that first, Srini.
Okay, sum. Okay, very good. Where is sum? Give me 1 second. You get the distance. Yeah, Sairam, what is the question?
Why did it get so many decimals? If you do it like just 1.0 minus 0.7, it will be 0.3, and square of that one, it should be 0.09. Why see like 0.09000002? Why do we have so many decimals after that?
That is computer. So
It's computer?
it is correct. It's computed accurate value. It's not, we round it. It does that. Okay. This is just to show you. Okay. So Saram, in the whole approach, you have 2 points. A zip operation can do this. You can find it. See, this type of things, don't get scared. I'm just giving a sense of it. You just sit with a friend or a book and see how Scala is doing it. So you start playing it. But you don't have to learn hundreds of these things. Few things like distances, how you zip it, how you fold it, how you etc. So Harun and I'll be making it comfortable more. But this is now just to give a sense of it for a distance. So I'll be using this in my Sarah, please.
No, I'm trying to understand what do we do for negative numbers, because if you look at the last one, 3.0 minus 3.9, which will be negative number, right?
So what is that? Yes, you did a square, Sarah.
Square is a positive again.
Oh, okay.
So you want to do just without squaring it. You might get.
So what is the zip doing here?
A zip is just like our zip, Sarah. Sorry, if you have a suitcase, what zip does? The one array, it has 2 arrays, one array on the top, another array top. What zip does is each element of that first array will map it to the corresponding element of the second array. Both arrays should have the same dimension. So if we have assume this is vector, but we convert it to array. This is a 3-dimensional array. This is array. So zip is doing tupling these two, making it together. DK 1 0.
Grouping the elements at the same position.
Grouping the elements. DK. Yeah, you're right, Harun. So DK, it is grouping these elements so that when you use a distance, you can do this. There may be multiple ways to do. This is one of the efficient way Scala does, rather this function does. DK, does it understand? The zip, what a good question, DK. Zip, what it does is group these 2 elements, these 2 elements, these 2 elements. Of course, you can do in one shot the whole thing. I've shown you in multiple steps. But you may be able to do one step. What is that? Harun? Arun will be helping you all these things. Arun, you know
Yes,
your
sir.
responsibilities as you always help. So,
Yeah.
but I'm putting a foundation for them. See here, one step is the beauty. Math.sqrt, you zip that, then you map it. What is that? You map it. Okay, you like the syntax, right? Then you, what do you do? Then sum it.
Srini, I think did you miss that one?
I missed.
Element 1 multiplied by one more time, right? Like
Yeah, it's a Siram fault.
Yeah, it's my fault.
Yeah. Siram doesn't trust even the computer system. You know, it's very critical. You know, it found the distance. See, one line DK. Okay, do you appreciate this, DK? Admit, though I am showing you multiple steps, because for insight, what it is doing, it is. Okay, let's move forward, guys. Okay, so this is one of the things we'll be using. Okay, for helper function. Let's move forward. What is our whole idea? Our whole idea is to get the data. We'll spend another 10 minutes to take break. Okay, let's move forward, guys. We need to go fast. Now let's come into the machine learning of this problem. I need to get the data. I need to do some cleanups here that is needed for machine learning, rather clustering algorithm. Then going to run the model. Okay. I have this data I'll be sharing with you. DK Sairam, look here. I have a raw data. I'm taking from SC for context, text file. I'm reading it a cluster train data. I'm taking simple two-dimensional data. So two-dimensional, just a point, a two-dimensional point to reduce the complexity. Then you can extend it to multiple dimensions. Look here, I'm going to run this and see what the data has. I ran. This is an RDD of string, DK and Sairam and everyone. You know all these concepts, RDD. We read, it's a simple data, but what this data contains? Let me take this data, 5 elements of this data, to see what this data contains. See here, Sairam, DK, everyone, please see. This data has a simple rows like this. It has a 1 point something. This is 40 points, then 0. It appears like a three-dimensional point. It appears like a three-dimensional point, but it is not. Only this is the point, Hema. This is a two-dimensional point. This is the two-dimensional point or vector. This is the two-dimensional. What this is some label. Hey, this point belongs to a category 0. This point belongs to category 0. Even there are other labels. This point belongs to maybe something like this. You see here, hey, this login came from the first year student. This login came from first year student. Maybe if this is 1, this login came from second year student. Something like this. This third one is label. DK, did you get that point, DK? This data, these are the inputs, which are the real vectors, real points. This is an optional data, a categorized data. So some may be thinking, okay, this data is already categorized. When we do clustering, maybe they cluster based on this category itself. That is also a possibility. We'll see. But this is a categorization variable, that's it. But not a real input point. This is the point. Okay. Now what I'm going to do is, DK, Sairam and everyone, I'm going to take these two elements and make it a vector. Because for machine learning, I need a vector. Right now, each one is a string, RDD of string. Yes or no, Sairam? Each line is RDD of string. Okay. What I'm going to do is, what I'm doing here, you please see. I may be doing a multiple steps so that you gain more insight. Some of them you can even do in one line. But get into this. What I'm doing is, Sairam, I'm taking this raw data, I am splitting this data because the comma delimited, comma delimited. So, and I'm splitting it, and after I split, I take the last element, which is this one. As I told you, first try to understand the code, read the code. Don't get scared to write the code. Writing part will go later. First, see here what it is done. It is taking, it is splitting. It is taking the last element. Then I want to see if for 0 how many points are there. Sairam, please see here. For 0 here, since I took 5 points, I have 5 points here. For 0, there are 5 points. For 0, there could be 10 points. I want to see how many points are there. Let's see here. Count by value, count by value. What it does, you please see. It does very interesting data structure out. DK and everyone, please see. When you take this, you split it, you take the last one, then you use a method called count by value. This whole thing will be split into a data structure map. Harun, did you introduce map, right, for the people? Or tomorrow you are going to talk more about it?
Yeah, we did map, Srini, last week.
Okay, basic map. Okay, very good. That's good. Sairam, please see what a wonderful thing you did. Let's see here. I will comment this and just see without count by value. Look here. Without count by value, what it is please see. It will help you to improve your code. You play around with syntax. Anything? Okay. Sorry.
Do you need to put like val raw count equal to first to start with?
No, it should print directly. I split. Okay. When you split it, it becomes an array. Array doesn't print because array it store as an object. That should be okay. So what you do is when I do what is that last without printing, if you say val, you're right, Sairam. Let me dedicate this to Sairam. Sairam. Okay. It is still, you split it, get the element, it's still a RDDF string. So what this does is, if you use the last element and use a count by value, it is taking a last element and counting how many that values are there. When it does counting, it creates a map object. You please see here, interestingly. This just a count by value method, your S data, it became a map. This map, what is the map? It's a key value. Oh, it means DK. Okay. What is that? Zero category rows, I have 67. Emma. One category, rather, the zero first year student, freshman, 67 people. Second year students, 427 people. Third year, 336. Fourth year, 15. DK, we have some super seniors who stay more than 4 years in the campus, right? Sometimes we have fourth year students, fifth year students. It starts with 4. It's many. So it's a label. So this many labels, this many data is there. I just, I'm playing with it, try to understand. I'm just playing with the data to get insight about this. Please observe. You get used to slowly. But please observe. Okay. Next you see here. What I exactly want when I split my data, Sairam, when I split my data, Even though I know this many people are there, I really don't care about this last one. What I want is this data. Where is this data? This one, which is the I care about this data. This is the data that is input to me. This is the point. This is only a categorization variable. So I'm going to avoid that. I'm going to avoid that. So what I'm doing is I'm splitting right now. Come back, Tyron. I'm splitting this line. You're good with this? You know, I split this. I need to take each one. I need to construct a vector, right? You remember how we constructed a vector, Tyron? To construct a vector, I need to use vector.dense, the dense vectors. There are concepts called sparse vectors, dense vectors, don't worry. Dense vectors we use in this machine learning in the past. Right? Vectors.dense, you need to pass a double to that one. So let me get this. When my data is a string, I split it. When I split it, I get this, I get this, I get this. But I just want these two. Tyron, I pass these two into vector.dense. Look here. What I'm doing is, next I'm taking this raw data array, which I split. In that I'll take each line. Out of that, I'll take this first element. Rather, I will do in this way. I take the last element also. Last element I don't pass to vector. Tyron. See here, a line 2 means third element. Tyron. You see here what I did here? Leela, what I did here, please see. DK, what I did here? I took whatever I split from this. When I split, I will have 3 elements, you know. It's nothing but an array. In that array, I want to take these first 2 elements and pass it to vector.dense so that this becomes a vector. When I pass it, see here how I am passing? A line 0, 2 double. I want to make sure even the data, if there is 1, it to become a double. So here you see it is already double, but still I want to enforce that. A line 0, 2 double, Tyron. A line 1, 2 double. So this is the point. This is just a third one. I'm just keeping it for now. I'll remove it.
So is it like optional?
No. For here, I just getting more insight, some more insight. Later I'll remove. Actually, I want this only, Tyron.
Yeah, that's right. What I was thinking. I mean, yeah, the first one
you are right.
seems to be.
This is optional step. This is optional step. I just want to show you what happens. This is how you can play the way you want. So label, see, that's why I put it as a labels and data. What is the object? Emma, you please see. Labels and data has that label, which is the category, first year student or not, and it has a vector object. This is a tuple. See how beautiful the tuple is used. Still, this is Tyron and everyone. Still, this is only a transformation. So still, it is an RDD. Labels and data is still an RDD. Interestingly, what is this RDD? It is RDD of a tuple of type what, Tyron? A tuple of string, which is the categorization element. Okay. What is the second element? You please see.
It's a vector.
It's a vector. The vector. Do you remember other day people are talking? Hema told it can be RDD of object, RDD of object. Hema, do you recall this? This is RDD of different types. The RDD of string can be made to RDD of string, comma, a vector. See here, raw data array. Since you split it, it is RDD of array of string. The original data is raw data. Let me go back here. Hope I'm not confusing you. It takes some time to digest, go step by step. But again, there is a pattern. DK, see here. I started with raw data. How beautifully the types are changing, you see. R data is DK. It is RDD of string. Then I am taking R data, I'm splitting it. When I split R data becomes, since I split it, it is become RDD of array of string. Then in the split, I made into two parts. The third one, third element, because this is the data. This is the data. This is the vector. This is the categorization. So that's why I put that categorization here, which is still string. And this is a vector. For vector, I need to pass vectors.dense. I'm passing those two. This one, a line that 0 to double. This is DK, is that correct?
Yeah.
So when I run that, do you observe this?
Yeah, I have one question.
Yeah, please, sir.
So how do we know when we get a raw file? So how do we know whether it consists of a category or it has a 2-dimension, 3-dimension, or these points? So how do we make
That is a good
sure?
question. That is where Arun, you'll be collaborating with people who are sending it. Data doesn't exist by itself, right? It won't come from Mars, right? So
Yeah.
somewhere every data here and there, suppose it's there in Cassandra, it has a schema, or somebody given a file, there is some documentation, what it has, etc. Right? Yeah. So those things, will always be there in the industry. There will not be any orphans. There any orphan, they will keep Harun. Hey Harun, can you document what this data schema is, at least in the documentation? Yeah.
Okay.
It is not that I open the file, you know it. No, since I told you, you know it. Okay. I got this file from somewhere. That author told me. So we took that example. There is no mystery on it. Okay, guys. That's a good question, Harun. But hey, don't deviate from this point. DK, you need to endorse this. Do you observe how the data types are slowly changing? That observation is very important when you are writing these programs. If you are on mute, can you add one line? Okay, Hema, do you observe that, how it is changing? Last time, you remember on the orientation session, Mohan asked, or somebody asked, is it always RDD of string?
Yeah.
You told, hey, it can be RDD of any object. You remember?
Right. So this is an RDD of string and vector, where this vector comprises of a tuple again.
Exactly.
RDD of tuple, and the tuple has two types, string and vector, and the vector itself is derived from a tuple of.
Correct. Now, please, let's go to interesting. Hey, ultimately, I want this only. Hey, Sairam, you're right. I want this one. Now, look here. When I print this, when I print labels and data, if I print this, let me print this too. You'll understand. Sairam, what happened you see here? This one, I'm printing labels and data. So it is the label. I just took 5 rows. And this data, because this is a vector, right? Sairam? Now this is the second. Yeah.
I didn't understand one piece. What is that 2 double does? What does it do?
Oh man, 2 double is English. What it does? take this string.
No, I thought you used something else earlier.
No, from the file when you are reading, it reads as a string. So we are converting the string to double. So previously we declared that as double when it read from array. It already knows and it has read as double. But when we are reading from the file, so everything in the file is taken as string. So when we split, it creates array of strings. So that string we are converting to double. Actually, the value is double, but it is read as string. So string string conversion to data type to double. Because vector dot dense, it needs double, right? Data type.
Okay.
Right on. That's correct. The vectors dot dense, the vectors needs double as input. So anything you're passing is here, this is the array of string. So the string, even though it's a number, it is a string. The number is shown as string. So it needs a double. So, okay. Okay, very good. Now come here, guys. Hey, this one is here. I'm printing. This one, if I print, it has both the, what do you call, this 0. This is the key and value, because it is a, what is this? It is a string and this. So it is a tuple, a tuple of keys and value. Right. Now you see here, from the tuple, I am just getting the value. These are values. You can treat it as a key and value. Let me see. If I just say keys. Or let me run this. Everyone, please observe. It needs a lot of detail we are looking. Emma, what happened here? I have this. This is keys and this is a value. When I just say keys, I get this only. When I say values,
it's like a map.
I get the
value pairs. We can read.
I get the second pair.
Yeah.
I get this second. Right on. Okay. What this values does is it prints the second part only. Now you see separate. I can do this way, or here itself. If I remove this, I get the what you call the vector. But sometimes that may be enclosed in a bracket. But anyway, I think you can play it around. Let's not spend a lot of time on this. But did you observe, Sairam, how I got this? Sairam?
Yeah, I understand. Got it.
Okay. Now I have, so
Srini?
This is, please, sorry.
So is this a automatic function, like keys, values? All you did is you changed an RDD to a new map.
Correct.
So this is automatically available, like whenever we do something like this, data manipulation, and make one.
Yeah, they are available. So you may be thinking that how to learn all these things. Just take from examples itself. I'm doing an example. Maybe a few other open source or some other code, there will be examples. You see a couple of examples, you capture these valuable, frequently used these things. But still, we will direct you in the material I posted on Facebook. If you go through, you will find these things very useful. But let's focus for the class sake. You are right, Hari. These are all available. Because you don't want to spend a lot of time to write for each loops or just to do all these things. So that's where they make it higher level functions in this functional programming. So that will help you to handle these machine learning projects more easily. Okay, look here. This is the data we want. Exactly. Till now, I just counted. I'm going to count this. This is, now this is the data. Please see here. Yes. Sairam. In Telugu, there is a saying, Kondantovi Elakana Pettineta. So what all we did is just to get the data Okay. But no, I want to show you how to manipulate this. That's why. So your data is you're from these labels and data. You got the values. I'm caching it so that for the machine learning, people use in memory. In the Spark, you can say cache, so it will be available in the cache to process it. So I have this data. This is the data, the input data I'm going to use, and I printed decay. I'm taking 10 rows and printing for each line. So I have this particular data. This is the if you see here, if I don't print it, or it's okay, print it. See here data, Tyra, what is the data now? What is the input data?
It's a vector.
What is the input data? It's a input data is a Spark RD. It is still an RDD. Please observe. It's an RDD of a vector, linear algebra vector. This is the point, the input. I am going to use it for my machine learning library. So give me 2 minutes. We will take a break. So I'm counting this data. I'm counting this data. So this is the data I'll be using for my machine learning library. So I'm going to create a model and I'm going to create a k-means object, then run on this data. That is the idea. That is where I get the model. So we'll work on the break after the break. Hey, any questions, Tyron, till now? Till now, I didn't do anything. I just got the data, just did some manipulation, So as it's shown you this one, I got the data. I did some cleaner, prepare or manipulated data. I'm ready for we are ready for the training model, Sarah. Are you excited about this, Sarah?
Yes, sir.
Sound interesting? Excellent. GK, Leela, any questions till now? Okay.
No, Srini. Yeah.
Take a break. Excellent. It is 10:30. So here it's 9:30 in California time. We did a lot of details, so time runs very fast. We'll take 10 minutes break. We come at 9:40 of California time. And I'll take another question after some. Okay, guys. Welcome back, my friend. Okay, till now, let me check. You can hear me. Taj, welcome. Basavaya, can you hear me?
Yeah.
Very good. Mukesh, Leela, Lakshmi, Kishore, Kiran, Emma, Harun, DK, Narayana, Hari. Okay. Let's focus, guys. Just stay on all these just small string manipulations, etc. These are all needed, as you get this data, as you clean and prepare and manipulate it. So Harun is really expert in this to handle these collections, etc. He will help us to learn a lot of this stuff. He will make us comfortable. I'm very, very confident because he spent a lot of time. He worked with me almost 6 to 8 months to learn this stuff. So he has very deep insight. So it will be very helpful. So, and we have other support system, other people also, Nagesh and Hema and other people also can quickly learn and give us some seminars and equip you. So you're in good hands. But let's focus on these ideas, guys. As I mentioned, this is where you'll be doing all this manipulations, all this. Look, it's not a one-day task. You will be learning over a period of time, and there is a lot of code available in the internet, and a lot of communities available, a lot of blogs are available, a lot of examples are available. This is like a free knowledge. But this foundation will help you to explore these areas. So let's focus. Now I'm going to train the model. I'm going to run on the test. Come on, guys, focus. So how I'm going to train a model? Before I train the model, first I need to have a what you call k-means object. K-means means k. K is how many number of clusters you are doing. So that is k. Means it uses the distance. Rather, when it calculates the centroid, it's the mean of those distances. That's why it came as a research term as a k-means. So I'll be first creating a k-means object. You can use still val also. That is not a big issue. But the only thing is I put var because after some time I want to even override the model. Right now it's okay. You can even put val. That is not a big issue. So I created a k-means object. The simple k-means, new k-means. That's it. This is caps here. This is a variable. Hema. For this k-means object, I set how many number of Ks I want, how many clusters I want to make. I want to make 5 clusters for now. Then I will improve. I'll use a methodology to find out. There is a methodology called elbow methodology, where you can identify how many Ks you want, optimum K. I'm going with 5, and this is a k-means set epsilon. It is a learning rate as it does the iteration. It has to converge it, so it uses some hyperparameters. It's 1 into 10 to the power minus 6. Certain distance steps you can use into minus 5, minus 4. Usually, in the examples, people suggest, the documentary suggests use between minus 5 and minus 6. Something like that. It is not a big parameter, just some learning parameter. So I'm running this. I'm preparing my object, k-means object. This came from, everyone please see, Sairam. This came from this library, MLLIB clustering k-means library. It came, which we imported here in the beginning. That is good. So now you have a k-means object. Now very simple. If you take this k-means object, you run that k-means object, rather use the run method on this whole data. This data is an RDD. You run on this data, then you get a model object. You model object. What is that model object? Model object is also has a data type. Model object is a k-means model object. Emma, model is an object. Some people think a model is a string, or model is an integer, model is an object. K means model. What is an object? Emma can explain better. Object contains certain methods, certain, it has its variables. Yeah, Hema, please speak.
Certain attributes of a particular category and the operations around those attributes.
Exactly. Simple. It can be any object, even it can be your name. But essentially that captures certain operations, certain attributes. Okay, this is the model object it came. So this model, what is this model? This is a clustering model. This is a k-means clustering model. So this k-means clustering model has a number of clusters and centroid. Those are the main things if you have a cluster. Saram, is that correct? When you say a cluster is how many clusters are there? Each cluster has what are the centroids, and each cluster, rather which points belongs to which cluster. That is the characters, right? At least the major characters. Saram, do you agree with me, or you have any question?
No, I understand. Yeah.
This is the model. Hey, how many number of groups? What is the centroid of the group? Who belongs to this group? Each group. When it makes the groups, I made 5 groups. It puts again a number to it. Hey, this is a 0th group, 0th cluster, first cluster, second cluster, like that. This came from the model. Sairam, the other attributes which we omitted, this came from the data. This came from the data we already omitted. Whereas what I'm getting now, going to get some numbers 0 and 1, those came from the model. And even we are going to compare these two, this categorization and that categorization, to make sure is simply just making it what it is there. Let's see. So what I did is I have a model, I ran it on this. It went quickly because it's in cache and it's some 2000 rows already. It can run on even 2 million rows. So this model object came. Emma mentioned this model can have attributes, it's a functionality. So this is a built-in. This model have a cluster center. Cluster center is, one of the attributes. So look here, model at cluster center. I put, how many clusters are there for us? I put 5, right? I put 5 here. See here, I'll get, now see, cluster center. Center is again point, right, Sairam? Center means it's a point or a vector, right? Sairam, you're on mute.
No, cluster
point.
No, but the cluster centroid is the point, yeah, to center.
Yeah, here cluster centers means that only. Each cluster will have a centroid.
Okay, so we're calling cluster centroid centroid. Okay.
Yeah, cluster centroid. This is a built-in word for that. Model dot cluster center. The reserved word. Automatically you'll get hurry. How many centroids are there? You see, this is one centroid. It's nothing but a 2-dimensional point. It's a vector. See here, linear algebra vector. So this is one center. This is one centroid or center. What I'll use it. Third, fourth, fifth. You see, each centroid has a two coordinates. So one point has a 2 coordinates. If you have a 3-dimensional one, each point will have a 3 coordinates. Let me quickly run, because Sairam doesn't believe it unless you see it. I'm going to run 6. I'm going to run 6 clusters for the k-means. I'm going to run this on the data. I will use the cluster centers. Param, do you see? This time you got 6
Yeah.
here.
6
1,
center.
2, 3, 4, 5, 6. Right. These are centroids. I just listed. Next, just I'm doing a one particular optional thing. We can directly get into now training data and get the what you call outlier. But before I do that, I want to show you a few optional steps to get more insight about the model we have. So what I'm going to do is I'm going to list out few things. See, what I'm going to do is these are the let me run this one and then I will tell you what they are. Okay. See, Sarah, I'm going to now compare the categorization we have in the file with the cluster number and how many points are there. Let me show you here. This is 25941. These are the labels in the file. Like look here, the label. Labels from the file. How I get it, I will show you. These are the cluster number. 0 means first cluster. This comes from the file. This comes from the model. I want to compare. See, you see here 2. The third year students is going to first cluster. Interestingly, okay, 2 is okay. Take the 0, like 7, 8, 3, anything repeated, everything went to the same. As you see. Second, yeah, see here. This is 0th cluster. 0th cluster has third year students. 0th cluster has 10-year super seniors. 0th cluster has 5th year super seniors. 0th cluster has, so one cluster can group many labeled vectors. Please note that point. But how we got this? Let me show you this. Again, walk you through this. This simple function, I thought this would help you. It is optional step. See, I have a RDD, it's cluster and label. Sorry, let me put it. I think I'm confusing you. See, I have a labels and data. Sairam, does it mean it has a label and data, right? Both?
Yes.
So that labels and data, let me labels and data. What it has, Hari, it labels and data has a label from the file, label and the data. Now I'll take each label, take the label, and I will take each data point. Then map it using a map functionality. Let me take this. You may be wondering why you need K. Look here. I'm taking a label, I'm taking inputs. This is nothing but a tuple. Right? This is a tuple. So I put as a tuple. This is a label. You can put any variable here. This is the label. This is the data, each one. I'm taking one row like this, and for this point, I will get the cluster number, which this point belongs to which cluster. So something like this. This is the categorization label. And this point belongs to which cluster? Look here. I pass that point to that model paragraph. Model.predict. If I pass a point, I will get a variable called cluster. I'm putting it as a simple cluster. Then the output is nothing but, that cluster is nothing but which cluster it belongs. Which cluster it belongs. So I'm taking labels and data, I'm mapping, I'm taking each label and each point. When I map it, I can even write multiple lines. That is the beauty of Scala. Till now, when you map it, if you map x to, you can map it to x squared. I can even map taking an element of this RDD, map each element decay. Each element means it's a tuple. There's label and data. I just put some variable. So for this data, Sairam, I need to find out the cluster, yes or no. Sairam, tell me. This label is a constant which came from the file. For this point, I need to find out which cluster number it went. It went to 0 or 1, like that. So what is this statement, Sairam?
So predicting.
What is this statement? You are predicting.
You are trying to find the cluster number.
Cluster number, exactly. So you got the cluster number from the point, and you're putting an out. You're again putting them into a tuple. So you have a label here. Whatever you input, you are passing output also. This is the cluster number. If I remove this count by value, what it does is, hey, how many points went to which cluster? Which cluster? So let me run this. If we need, we will go through this. This is an optional step. I don't want to stop it because of for some reason. So I don't want to stop this just for this function, but I will walk you through this. If needed, Harun and me will explain this again. So here, if you see, Sairam, what is the error it says?
The expected type requires one argument function accepting it.
What it says, the expected type requires a one argument function accepting a two tuple. Consider a pattern matching anonymous function like case. See, they gave an example also how to use it. So there is a function called case which helps you to take certain input data types and can do manipulation on those inputs of those variables, inputs of those functions. This case is a pattern matching functionality, which Harun and I will help you. But just for now, please use it. This is an optional statement. If I use it, if I run this, it's a simple optional. What it says is, hey, this label, two label data, have 336 points of two label data went to 0th cluster, which is first cluster. 182 points of 5 label cluster, sorry, 5 label points went to cluster number 4. BK, 427 points of one label, one label points, 427 points of label 1 went to third cluster. Okay. I know there is a little bit confusion here, but can we move forward beyond this, BK, from here? But the output, the expectation is known here, right? The simple utility, what we are doing is, hey, what is the, how many number of points of which label went to which cluster? BK, you're on mute. Sairam, Emma, can we move forward on this?
Are we doing any iterations here, or is it?
Yeah, see, it is basically any map does the iteration, right? It is just, I want to know, hey, this is the labels and data. How many points went to which cluster? And what is its label? You see 36 points went to 0th cluster, which has label 2. See, there is another 0 also. Click here. 66 points went to 0th cluster, but it has label 9. Separated. Okay, anyway, please, you can reserve this for additional discussion tomorrow, because this function has no bearing on finding our aim outlier. This is just to give you additional insight about your cluster you have built. I'm moving forward. But what I did is, again, in one minute, is say, I want to count this. How many points went to which cluster? I'm going to do a count by value. Count by value. By predicting each point went to which cluster. But that point, I'm passing it as an input in the map. Input. When I'm passing it, not only the point, I'm passing it as also label, so that I can compare the label. And so I need to pass it to a pattern matching function called case. If you don't put this, it is telling you, hey, you can't do this whatever the way you pass. You can't just pass, and because then you are going to take this, because here you are taking tuple, and simply you are saying data 1. So it is difficult to do it. That's why it says an example case. Pass it to a Scala functionality called case. What case does is, it does the pattern matching. Oh, case of label and data. I can take data. From the data directly, you pass it to the model, so that you get the which cluster. So I got the cluster. The label is already anyway passing. You are passing it. You can take it. Label I'm taking as is. This cluster I computed in this function. The cluster is which cluster this point went. So I got that. Then I counted the value. Counted the value means it groups how many points went to one particular cluster. So anyway, I am running this. I get this output where it says 336 points went to 0th cluster, which has a label 2, etc. I'll come back to this tomorrow.
Before we go, just one question. So this model is an inbuilt function which you are using to find the this number of points which went to each cluster. So that model itself is an inbuilt thing which you are using, right?
Let me say, that's a good question. See, what is inbuilt and what is not inbuilt? Let's get into this. Let's now. So in object-oriented programming, reusability is a main advantage. So people build the libraries so that you can reuse a lot of things. Somebody built another layer, you can reuse more. You can reuse more. So you are right. This model came from a k-means object. When you run that k-means object on this data, so this model is built by us, which is not an inbuilt function, but it came from a k-means object when you run it on the input data. This k-means object you have built using a statement new k-means, which is part of this library. So this library has that functionality built. So you can think it as a built-in functionality. So from this built-in functionality k-means, you ran it, you got this model. So that you, from that model, you are getting cluster center, which is again a built-in functionality.
Why I was asking that question. We are finding, say, you said, maybe when you are doing this, you may get a 50% or 60%, but that is okay. Then we can correct, the program. So, is it modifiable? That say, suppose I get the result as, like, say, the count which I wanted not satisfied or below the level which it gives. So, if I want to do some correction, is that possible or how is it?
Yeah, see, first try to understand here. See, the model came from where?
From the k-means.
K-means is only vehicle. K-means is only Chennai Express. But the people in the Chennai Express is the one which decides
correct
the output, right? So this is the driving thing. This is just a computer program. So this, whenever you are right, the model means this is a machine learning model, Hari, right? This machine learning model, your model is good if your learning is good, right?
Correct.
So your learning will be good if you have more inputs. Somebody say, hey, one politician is an experienced politician. This means they have more inputs, more data, all those things.
Yeah.
So the learning is good if you have more data. My model is only 50% efficient. So it means it has to learn more on the more data. That is the idea. Okay, Hari. Does it help you to move forward?
Yes. As of now, good.
Okay, let's move forward. Let's complete this because that is a later part. Okay, very good. Now you see, guys, let's go. We need to move a little bit faster. Okay. So what I did is I created my model. I tried to see at which point went to which is also an optional step. Just I want to get a more insight about my model. That's why I'm playing with that string. Definitely, it might bring a little bit overweight to the people, but let's not deviate from our process. Our process is this: we are trying to do. We train our model, and we are going to test now on this data. So, Sairam, I'm going to get the test data now. I'm going to get the test data now. Where is my test data? Let me get the test data. My test data. So this is, I'm going to get my, where is my test data? Second. I'm splitting here along with test data. Sairam, please here. Now I'm going to get the test data. So I have a different by cluster test data. Earlier, mine is a train data. So I use this, run the test data. Again, I'm doing just like earlier, what I did for train data. I'm splitting it in and again seeing it. That has also labels. And I need to split just like our training data. I need to prepare test data also. Just like train data, I need to prepare it. So I'll split it again. When I split it again, I need to remove this particular label. I need to pass the second parts into vector. This is for the test data Sairam. So I'm running this again. This test data. So my test data, this is my test data now with label. Labels and data, I'm just saying anomaly data. Or let me say raw anomaly data. Let me say raw test data. Labels and data, let me say test data. So this test data, Sairam, I'm just dividing it to this and this, just like earlier we have done. Now I'm going to.
Srini, you need to change the variables in the second line. Raw anomaly, raw test data array. Line number 5.
This one?
Yeah, next line. You have to use that array, right, that was created.
Okay, you're right. Okay. Okay, guys, this is the test data. Again, I'm preparing this my test data. So how I'm going to, I have a test data now, how I'm going to run my model on this test data and see which is anomaly. I prepared this, my test data is ready. I'm going to apply this model on this test data. When I apply it, what is my aim? Sairam, Hari, DK, Hema, Nagesh, Kiran, what is my aim? How I find outlier? Don't you think we need to use our strategy? Outlier is the point, the test data may fall into cluster or maybe an outlier. So some points of test data may fall into the cluster, some points may be outlier. Which is the outlier? We need to use the threshold, right? So any point whose distance from its centroid is above the maximum threshold, I will call it as outlier. So for that, first I need to find out the max threshold for each cluster. I'll use the one of the maximum one. Okay. Then, don't you think I need to compare this distance with this? Let's do that. So let me find out the maximum threshold. Then I pass this data, then find these distances and compare it. Okay, it's not difficult, guys, just need a little bit focus. I know we're discussing many things. Some people doing this whole thing in 2 classes. If they're doing in 1 class, that's good. Please focus. Okay, guys, let me go here. So for that, I'm going to use 2 helper functions. 2 helper functions. What are those helper functions? The distance formula. So this I already explained to you. So this, Sairam, I have a function which calculates distance. For the distance, I need to pass 2 vectors, A, B. Then it takes math that square root, it does the JIP, then find out this is the distance. So that is number 1. Next function is what I need, Sairam. This is a okay, distance function.
Distance from the centroid?
Distance also, right? Distance of the centroid also, I need that. But I'll use this distance function even for this. But this time only thing is, I need to use this input, right? Okay, this is a distance function. This is distance to centroid. Okay, how to find the distance to centroid? Whenever you talk about the centroid, a distance to centroid. First is you need that point. You need a point. Sairam, is that correct? You need a point as input. This is the input point.
We need the centroid.
Distance to centroid. I'm talking about distance to centroid. Whenever you talk about distance to centroid, you need a point. And for that point, you need to know the centroid of that point, right? Suppose I have a point. If that point belongs to this centroid, I need to find this distance, not this distance, right? Right on? Right on.
Yeah, I'm soaking in.
Soaking in, I know. But you see here, I'm telling you, distance from this centroid, if I have a point, I should take the distance from its centroid, yes or no?
Yes.
Not from the other one. It's centroid. How? Suppose I have a point. How I know this belongs to this point, this point, this point? Don't you think I need to use that model? Otherwise, how I know? See, I given you a random point. Random point. How you know this point belongs to this one, this one, this one? You need to bring the model into picture, right? If you apply that model onto that point, you will know it's centroid, right? Yes, that is correct. So you want to find distance to centroid, your input is that point alone. But that for that point, you need to find its centroid. To find its centroid, you need to bring the model into the picture. The model we have already computed, model object. So this point, any new point, that model we computed are the inputs to a function called distance centroid. So let us use that. Okay. Using the model, using the input of that point, you can find the cluster number. Yes, we already did that, cluster number. And using that model, you can also find the centroid of the cluster. Here, model, cluster center. Cluster center for what? Whatever the cluster of that point. Yeah, guys.
Yeah,
everyone.
Srini, correct me if I am wrong. So right now we are using the built-in intelligence of the model to find the centroid and to which centroid the distance should be measured from.
Exactly. You are right. Sairam, DK, and everyone, just focus 10 minutes. We have a point. Hari mentioned a good point. Hey, we already calculated a model. This model has intelligence or whatever the functionality. If you pass this point to this model, you get what is the cluster number. And for that cluster number, using the model, you have a cluster center. This is the centroid. This is the centroid you got. So once centroid is a point, data is a point, centroid is a point, data is a point. These 2 points, you are passing to a function, a distance function. Distance function, you get the distance to centroid. So Hari is right. Hey, we got a point, input point, because to know the distance, I need to know the 2 points. 1 point is already known, which is a input point. I mean, each vector of a test data is input point. For this input, we need to know the centroid. Hari is right. Hari says, hey, using the model, I will use the cluster centroid for that cluster. But that cluster number is model.predict and pass that variable. Sarah. Tell me you got this or not. Otherwise, I will not move one inch. We'll meet tomorrow.
Sairam, please.
Sairam.
Yeah, I'm listening for first time, so I'm little overwhelming, but yeah.
No, I know.
Trying
See,
to understand.
you got some math, some first time, but again, that's why I'm checking. Otherwise, where do you think?
No, but I understand the concepts. Yeah.
Yeah. DK, you want to comment anything on this? Is this cool for our friends? Is it little overwhelming? We have a point. You're on mute. Kiran? Nagesh?
Yes, Srini.
My function. Let me check with Leela. Leela, hey, I have a point.
Okay.
I want to know the distance to centroid. First, I need to find out the centroid. How I find the centroid? A model that using that model, cluster center, using that function. If I know the cluster number, I know the centroid.
Yeah.
But to know the cluster number, I'll use model.predict for that point, right?
Right.
So I say I have a point. Using that point, using the whole model, I'll find the cluster number, 0 or 1 to cluster number. I got the cluster number. For that cluster number, using that model, got the centroid.
Okay.
So got the centroid, found the cluster number for that point, using the model.predict for that cluster number. For that cluster number, I got the centroid. Using that model, I got the centroid.
Okay.
Centroid is a point. Input is a point. For these 2 points, once you know, you can call this distance function. This is a general distance function between any 2 points. Give 2 points, it gives you the distance. But I'm giving centroid and data, so I get a distance to centroid. So these 2 functions. Okay, I'm going to use this to find the threshold, this threshold. Then I compare this to this. So that for each point I will do it. Every point I will do it. That way I'll know the outlier. Come on, guys, just tight hold. Sairam, lot of things. Okay, I got the what you called. Let me come here. Those are helper functions. This is the test data, my test data. This is my test data. When I ran my model, I ran on the training data. Let me go to again from beginning. When I came here, this is my training data. Please hear, Sairam. You don't believe, that's why I'm showing you this again. This is the training data. I have these 2 files, I'll give it to you. This is raw data. This raw data I trained. Which I got the model. Then based on the model, my model is ready. Based on the models, I know the centroids, etc. Now I'm going to apply this model on this new test data. Where is this? New test data is here. I have a test data that also has a label and points. So label and points, I need this only for test data also. This is the point. This is the point. Okay. So let me, give me 1 second. Let me find the threshold value. I have functions jumbled here and there, but I will show you. Okay. Now look here, guys. Let me find the threshold. Not here. Sorry. Give me 1 second. I have this helper function. Okay. Let me not confuse you here. Let me make it a little bit bigger. Where is I need to find the threshold. Okay. Now come here, guys. So when I am finding, Sairam, when I am finding the max distance, I don't care about these points. First, I'm just finding, hey, what is the threshold? What is the threshold? Threshold belongs to these clusters. Okay, how I'm doing it here? I have labels and data original. Okay. I'm getting those values, which is the second part of it. Second part of it, which is the vector. I'm taking each point. I'm finding the distance to centroid. It means for each point I'm finding the distance to centroid. Look here, Sarah. Distance to centroid is a function. If you pass each point and the model, the output will be all distances. All distances. Out of those all distances, I'll take the maximum distance. I'll take the maximum distance. It's okay. I don't want to print it. I don't care. Sairam, the distances is, these are all the points. All the points means all the training point, not test points, which we already clustered. These are all points, training data, which we clustered. Out of all the points, I'm finding the distances. What is distance? All the points.
So, just a short question here, Srini.
Yeah.
So now when you're finding the distances, if I understand correctly, you are finding the distance from the centroid, right?
Correct.
Okay. To the respective centroid. That is, if there are 5
exactly
clusters,
respective centroid. You're right.
Okay.
In each cluster.
That is, yeah. So that respective centroid calculating function is here. I'm calling that function. This is the beauty of functional programming. You can pass the function into your program. This distance to centroid is the functionality. So you are right, Hari. I am passing this variable into this to distance centroid. I'm passing the model, and interestingly, this will calculate its respective cluster, respective centroid, then distance between each point to its respective centroid. You are right. So I got all the distances of each point to its respective centroid. Out of that, the maximum of it I'm putting in a threshold. It is a one-time calculation. Whatever.
that is where I have the doubt, Srini, because now you are saying respective centroid, right? So when you say maximum, so see there are 5 centroids. So how do you know? Because if there are 5 centroids, there could be 5 maximum distances, right? You can't,
no, 5
that's what I'm not
centroid
able.
means, of course, each cluster has its own max, definitely. Out of that, I'm taking the max of, see, one may have 5, one may have 10, one may have this one. But I'm putting 10 as the threshold.
No, that's not my question. See, if there are 5 centroids, say for example, and there is, say, like 100 data or 100 points. Out of that 100 points, for the first centroid, there may be a threshold. So how do we find for each? Is what I'm asking.
No, each one have its own threshold. But what is the maximum threshold? Not each one. See, what I'm saying is, each one has its own threshold. One has 5, one has 6, one has 10. But take 10 for now. See, you are doing a learning, right?
Yeah,
learning.
Sure. Sure.
So
Sorry.
let us do it. Let us see. Then you control a threshold. You want to reduce it. You want to that you'll figure it out.
Okay.
Okay. I have now threshold 34 point something. That is the distance threshold. So any point which is more than 34 from its centroid, I'll call it as outlier now. For now. We will change if you want.
Srini?
Yeah.
So you're establishing the threshold based on the training data or test data?
Training data.
Okay.
Because now I'm not even going here. This is my model. I have clusters. For each cluster, this is the maximum. So this is the maximum. This is the maximum. This is the maximum. Take each distance actually. Out of that, this is 5, this is 7, this is 8, this is 10. Now let's call threshold as 10. Now. Suppose even this guy is here. He is at 9. Okay, for now let us call this guy is belongs to this cluster. But if he is here 10, more than 10, even though threshold we took from here, let's call him as a far from this group. See, some criteria you need to establish, right? So my request is you don't get stuck here. You can go and think, etc. This doesn't change your system upside down. Let's start somewhere. You know, this is what you need to be holistic when you are doing machine learning. That's why the word is called learning. You need to build some criteria. So you're right, Kiran. I'm using only this data, training data, using that model. I'm finding the maximum distance of a point. I'm calling it as a threshold. Kiran, is that okay?
Yes.
So anything beyond the threshold is like outlier.
Yes, that's what we want to call. That's what we want to call. That's fair to say, right? That is fair to say, right?
Yeah.
Okay. For now, okay. Now I have it. I'm going to test data. And test data also I'm preparing it. Test data also I split. I have this one. But again, test data, I want these points. So that's why okay, let me call. This is the labels and data test. Okay. So, okay, I already have. So what I'm doing is I'm passing the whole thing. I can even pass just to this value, but I'm not passing it. I'm using a see here. I'm finding anomalies. However, I'm taking this test data, Kiran and everyone, taking this test data. I'll tell you why I'm using filter. So I am passing this label and my data into a case statement. Then I can do whatever I want. I can take this data. I don't care about this label now. Sairam, this data is from the training data. Sorry, not training. Test data. See here, labels is the test. So I am finding the distance to centroid now. For this data, so using the model I built, so if this centroid, distance to centroid of the new data, if it is more than my threshold, where is my threshold? My threshold is this one. I want to say even maximum threshold. Let me say max threshold. Let me run this function. Okay. Going back. Hurry, please see. Now this is, I am applying this, Kiran. Now I am applying this on the test data. So it means new data that comes here, new data that comes. So now for this point, for its centroid, or if it is here, it's centroid. I'll find the distance. If this distance is more than the maximum, I'll call it as a outlier for now.
Correct.
We'll debate if that is not a good approach or not. We'll debate later. For now, I'm taking that. So look here. I'm taking this whole test data, including labels I'm taking. Label and data, but for data I can take directly if it is in the case structure. But the data, I'm passing it to distance centroid. Hurry. Distance to centroid. I'm passing the model. So automatically, this distance to centroid only calculates the distance to its centroid only. So this distance, if this is more than threshold, I want those points only. That's why I'm using this filter statement. What this filter state does is, it takes this RDD. In this RDD, it filters. It gets all the points which fills this criteria. So this criteria, whichever is more than threshold, that data only gets filtered and put into anomalies. This anomaly is also an RDD. So it's the whole thing is a transformation. Then I'm going to print them. I'm going to get this anomaly. I'm going to take 10 rows. For each, I'm going to print. Or for that matter, I can count also. I can count. I can, instead of take, I'll say collect. It can take all. Collect. Okay. Let me run this. When I run this, detect anomalies or outliers. This one I gave some statement. Hurry. This anomalies. I got point number 1, point number 2, point number 3. Including label, I have printed. Including label, I have printed. So label and data. 3 points. Now suppose
Srini,
threshold. Yeah.
I think you have to use max threshold, right? You're using threshold, or is it wrong? Or am I wrong?
Oh, you're right. You're right. You're right. Yeah, threshold. You're right. Threshold is. You're right. Look here. It is 3. Suppose I use my comparison. I want. No, let's not use max. Let's give some. Let's not be too strict. Let's be more strict. Let's be more strict. Can you hear me? Let's be more strict.
Yeah,
we don't want to give this much room. Nagesh, you're right. Thanks for pointing it. This is a suggestion. No, I don't want this one. I want to be a little bit here. You know, even this guy is a outlier. Let us go. So anyone new guys, anyone in above go out of this border. I don't want. Just see, let us see. The learning means what? Hey, you apply it. Somebody say you are using your credit card left and right, here and there. Nagesh finished his project. He got some bonus. Now he got some savings. Say he wants to do a Europe trip. He goes and buying a lot of things. Suddenly, his credit card, they stopped it. It starts denying after a couple of transactions. What is the worst that happens? Nagesh will call the credit card company. Hey, where did you guys stop my transaction? No, we found it as outlier. Is this? Are you the Nagesh? Yes, sir. Oh, okay, no problem. We will honor that. That's it. That's how the business runs. Nagesh, do you agree with me? So, hurry.
Yes.
So, what was you are building a system just as it learns. So you will be moving certain parameters. But first to try to understand how we are doing it. Then we'll see different strategies. So this involves a lot of things we are doing. So you have a test data, Kiran. The test data, you found the maximum threshold from the existing training data, but you are applying the we applying this now, the strategy, which is a outlier detection strategy. We want to find the distance. This distance, if it is more than the threshold, whatever we fix, what we fix will decide later. For now, let us all agree only one max distance. One max distance. So this max threshold, we found it. When we find max threshold, definitely, Kiran, you are right. We should not use any new data. We should only use what is the training data, with which we found the model. We found the model. That is, we got the distance, maximum threshold. We use the helper function. That one, the maximum threshold, you are comparing it to the distance centroid for the test data. For that, all the test data, the passing label and data. That data, for that data, using its model. Its model means model is the same. Model is the same, but centroid changes because for that model, based on the point you are passing, Sairam, based on the point you are passing, the centroid changes. Centroid changes means it will have its own centroid. So, Hari, and you are right, this is nothing but its point and its centroid. So, if that distance is more than maximum threshold, you get it. So, that's what it is. It is what exactly is the data. So, if the threshold, no, we want a little bit linear, let's put 2. We are getting more. Let's put 1 more. We got less, 14 we got. Then we put,
yeah, so that answers my question, Srini. So we can control the max threshold and how much we want our definition with that.
Exactly, Harry. Exactly. Guys, please, before I summarize it, let's go to another important step, which is we found using the model, on the test data, we found the anomalies. Then going forward, you can apply. You can apply on the new data that is coming. We tested, okay, you are controlling how much you want, threshold -2, threshold -4, or threshold you want to use. You guys will decide. Your team will decide. Your bank will decide, working together. Then you apply the whole thing on the new data that is coming. Of course, how you deploy it, how you deploy in a real-time detection system, how you deploy in the batch system. That when you do a project, you will figure it out. Right now, focus on the central. What is the machine learning system or logic? How we are building it. Then how to make it a real time. That is a different architectural issue. Let's not go there for now. So how to improve? Last step is how to improve. So what is the K I should use? What is the one improvement, as Hari and we have been discussing, is this threshold. Now, how about the parameters? Do we get a best result when we have a K is equal to 2 or K is equal to 3, K is equal to 5? Not only results, even the computational learning, how it will be good. So that is called the last step improvement. Yes, let's focus on the last step, then we'll summarize it. Okay, for that, I'm going to a concept called clustering score. Clustering score. So my clustering score, I will use the. Okay, let me mute.
Sorry, mute everybody. There's some lot of background noise. I don't know from where.
Yeah, I did mute. Okay. Yeah, thank you. So thank you guys. So just stay hang on before I summarize it. Another 10 minutes. Please focus. So I am going to take case 1 to 30. My case 1, K is equal to 2, K is equal to 3. Any 1 to 30, I'll increment by 1. And this is a syntax where you want to do a range 1 to 10, 1 to 30, 1 to by 1 means 1, 2, 3, 4 like that. I'm taking this data. This is the K values. I'm using a map. That K value I'm passing to a function called clustering score. clustering score. What is the clustering score is, we want to say which is efficient system. What does it mean is, clustering score means, what is the average? What is the average? Rather, let me put it in this way. What is the sum of all the distances of all the points to its centroid? It may sound a lot of math, guys. Yes, I know a lot of things I'm saying to you, but this will sink into your mind slowly when you see this recording again. Sairam. Okay, let me give
Sorry,
a social
can
statement.
you say what we are trying to do here? Not clear.
Yeah, again, Sairam, please. Hey, you like closed knit communities, or what is what do you mean by good community? Good communities is the way our we have villages and towns together. Don't you think they're staying together? They're close.
People care for each other.
I don't know about care, but at least they live together in nearer, so that you have a nearer hotel, nearer hospital, nearest ATM, etc. We live in a Hyderabad, in a small colony, not a posh colony like my friend DK, where they live in Kokatpalli, Yapur. Then they have to come out at least 1 kilometer to come to a shop, because they live in a closed community. They have to come. Whereas we live in OE colony, where we step out immediately. There are shops, ATMs, etc. So what I'm trying to say is, these communities, when they're built, they do such an optimum proximities. So general here, when you say clustering score, what is the sum of all distances? If it is minimum, don't you think these are closed knit clusters? So, Hari, answer to your question is, what I am trying to say is,
yeah,
if there are different Ks, if there are 1, 2, 3, 4 clusters. See the distances, sum of all the distance.
Okay.
Sum of all the distance. Okay. And give K is equal to 10. See, K is equal to 10. K is equal to 9. K is equal to 5. For each K, see how close knit these communities are. If distance is this, if it is a minimum, it means it is more close.
Okay, what you're trying to say is the average distance is less.
Let me see if it is average. I don't remember if it is average or just sum of it. I think it's the average, actually. It is not sum. It cannot be sum, because sum varies. Let me come back to helper function. I'll show you that function also. Give it to you. Exactly. It's average. The average distances of all. The distance to centroid. Distance to centroid of each point for its own centroid. Their mean. We are going to compute if that the average distance for each point, if it is low, if it is more, I'll give you the credit score, like scoring 10, scoring 9, scoring. The best score is minimum score, right?
Right.
That is what I'm going to do now. Then based on that, I will decide what K I need to use. Hari?
Yeah.
Sairam? Okay, very good. See here, clustering score function. For this clustering score function, I will pass the whole data set. What data set I need to pass? My clustering is a training data. I'm building a cluster. I'm building a model. I want to improve my model. My K, parameter K, is good or not, which has a better score, Emma. I want to use on the training data. So I pass my training data. That is my input. I will pass the K. K is equal to 1, K is equal to 2, etc. K is equal to 10, like something like that. Those are my inputs, for which I will find the clustering score. What is the clustering score? Then, okay, I will compute the model for that K, because if you remember earlier I hard coded this. See here, K I hard coded. So my K means my model is built based on this 6, but now I am generalizing it. My K I'm generalizing it. Hari, Sairam, a lot of things, but we'll revise if needed. Sairam, I don't know.
Sorry, I'm asking more questions, but
No. Actually, Hari, your questions are really helping everyone to think.
Okay.
If I just to speak, what happens is a lot of things. Let's go slowly. They'll get into. You are asking very good questions. I really appreciate. You have a data. Your K is we are going to change. For each K, I'm going to find out for each K for the training data, Emma, I'm going to find out the clustering score. How I'm going to get? I will run the K means again. I will K means set K. Earlier I hard coded this K, Emma. Now I parameterized it. I set the epsilon. These steps are not new to you, Sairam. I build the model using that data, which is our training data. So then for that data, I'm taking each point and find distance to that point's centroid, and I average it, mean it. That will come as output for this function.
Yeah, clear.
Very good. Excellent. Sairam again. Leela, I want to find the first, just like your credit score. Somebody say my credit score is 620, 650, 650. How we are getting it? They have their own parameters. You're spending many things. It's not just how much debts you have, how much income you have, how many defaults you had earlier. Lot of things. But the mistakes, how many late payments you made. Lot of things, like a credit scoring, some parameters. But here, we use simple parameters. We are taking it's a K-means algorithm. Our score is, clustering score is, how the average distance is, which is the minimum. What is the minimum average? So my training data, K, I will be changing it. For each K, I will calculate the model. Sairam, Leela. And for each data element, I'll find the centroid distance, and I will average it. Again, does it sound good?
Yeah.
Are we trying?
Okay. Let me run this function. Yeah, Leela, tell me.
Yeah. Are we trying to find out the ideal number of clusters for the given data set?
Exactly. How many? You are absolutely hit the bullseye. What we are trying to do is high level. What is the K? Which is how many clusters we want. That is what we want to use. So let's use it. See here. I'm running 1 to 30. You can decide 1 to 10, 1 to 20. We will see. We will understand. And I'm taking each K. For each K, I'm passing that K to. For each K, I'm getting a tuple. The tuple is K, and whatever I pass, I'm getting it. And for each K, I'm getting a clustering score. For the clustering score, data is the input. Data is the input. So let me run. What is the data? Sairam, do you remember our data is training data? Let me go to that variable. Share the code to you. You can, I'll clean it and give it to you a little bit. Not anomaly. When I run the code, you will know your data is fixed. As Hema said, for our data, this is the data. For our data, this is the data. Sairam, labels and data, values which is cast into data. We counted 2000 rows. And earlier we ran the model on the data only. Do you remember? I'm taking that data only. That data is fixed. The only thing is now, as Hema said, for the data, what is optimum K? K is the one which is changing. Look here, I'm running 1 to 30. I'm running for each K. We are running the whole steps. Okay. Come on, it's running, you see. It's doing many Spark jobs. It will start printing here. Wait, let it run. Many jobs, because 1 to, in many cases, it has to run. Let it run. Another minute, 2, 3, 4. Look here, let us observe the data. Everyone please observe. This is K is equal to 1. The average distance is 47. 2, 34. 3, 18. 4, 12. It is decreasing as the clusters are increasing. Sairam? 5, 7, 6. Here it reduced drastically. See, 47 to 4 is 12. 7.
One question. Is it for each point? Is it for each point that it is showing, or
each K?
Each
cluster. K. But this is the average of all the points, right?
Yeah. Okay.
It is average distance. Average means
average
what is the average
cluster.
distance? Not each cluster. The all cluster. Cluster score, whole cluster score.
It's like if we use one cluster classification, the average the average distance between the centroid and the maximum distant point is 47. If you want to divide it into two clusters,
okay,
the average will be 34.
Okay.
So now we have to find out how many clusters will be the ideal number for our given data set.
Great.
Yeah, that's correct. So Hari, I got your point, but it is average of all the distances. One cluster, even if you have 4 clusters, one cluster average may be 8, another cluster may be.
So this will basically help us to decide how many clusters you want to go for.
It's an overall score. It's overall score. 4 clusters, always the score.
Through the classification size.
Clustering. So 6, but come on guys, see what is happening. As the cluster is increasing, this started decreasing. But after that, nothing is much changing. 3.3, 3.12, 3.23. You see, it is getting optimized. 3, even 2. Even at 13, 2.93, but 14 it increased. It decreased. But 6, 6, 6, 2, 4, 5, 3, 5, 3, 7. Still, nothing is changing here. If you see here, not much, right?
Right.
So you will decide you want to have 12 or 13. What happens is if you increase the cluster, you are using more computing power, right? You don't want to even do that. So how much you want to improve, we'll see. Okay, let's go. What is the number you would like to pick up, Hema? By looking at these numbers, it doesn't matter. One this side, that side.
Yeah, 9 or 10 is the optimum. Because after that, it's
9, 3, 10, 11. This is also good. But I let me go. This is actually good because 3, it is not changing much. So you choose between this or this. Let's go. It doesn't hurt. As I told you, this is a machine learning system.
Srini,
Not a
wouldn't
world
we
ticket
remove outliers and calculate this?
Let us see. That is a good question. That is a good question. We will run again. Let's use Hema. Hema, what did you say? Let's say 10. Let me go to 10. Let me go to 10. Let me build my model again. Where is my program? Of course, you can pass them as a parameters also, but for now, our program is going like this. So I'm using 10. 10. Even not only number of outliers, even the outlier points itself can change because you changed it. I ran it. Again, I'm building the model with the 10. So my model cluster center, because I have 10 points theorem here. So this all is okay. My, what we call, I will run my input is okay. I have these functions already. I just changed my model. But this I need to run. I need to find out now the distances changes, threshold. Okay, earlier threshold is from 27 or something. My threshold changed. Now I'm going to run the anomalies. Anomalies here, not 10. This is before, I changed it before from -1 or anything. Anyway, let me run this. I'll run again. Actually, no anomalies. With this 10.
No, I think you changed 2 or something.
Yeah, no, with this, because I changed my clustering, what you called my test data doesn't have anomalies. So suppose I have 1, still I don't have. For the test data. Of course, sometimes there won't be any anomalies. If there is no anomalies, what happens?
Shini, it should be threshold or max threshold, Shini.
Max.
Okay.
You have changed it, Max.
Okay. Actually, let me come here. Give me 1 second. This is this one. This is the function.
Okay.
Earlier I have 3. You're right. I have 3. Even see the points. 73, 73, 72, 72. This time I have maximum threshold, right? I'll run this. I have 2. Sorry for that, for the confusion. You're right. I'm using threshold some other thing. We got 2 only. Let me run again with the Hema set 10. I'll go with 14. I'll go with the 14. Where is my model? That's 14. 14 is my model. 14 is my run data. I will run the cluster for this 14. And I will find my thresholds again. Let me run these functions. It's okay. These are helper functions. This is the maximum threshold I will run. This time I got 14. Do you see? Earlier I got our threshold. We got 20, 24 or something. Then I will not use this. Let me go to this test data remains the same. I don't need to rerun this. My maximum threshold is 14 now. Yeah, but still what happens is based on the clusters have moved it, I have only one anomaly. So what is the summary? Hari,
Maybe-
so what did you understood at least to start? This is the first time you are seeing this approach.
Yeah, I think,
Everyone?
yeah, it's quite good.
Okay, excellent. Let's see the summary. Hey, we got the test data, sorry, train data. We got it, we cleaned it, prepared it. These two steps are same for train data and test data, because both we need to prepare it as a vector. Then we use a trained model to run on the training data. We got the model, and for that model, we found the thresholds also. We applied on the test data. Then we improved the K using approach called elbow method. Hema, Hari, DK,
Yeah.
everyone.
Yeah.
The value K, average inner cluster distance, this is the number of clusters, is starting dropping down steeply. You get some elbow. It is like our hand elbow.
Right.
Then onwards, it is not growing. So you choose somewhere here. Choose here. It doesn't hurt you. You can do trials. It's okay. Maybe you took this, after some time you took this. Your team will decide, hey, what is the thing we want to do it. So
Yeah, it depends,
you apply that.
on your data and what is the criticality of the data you're looking at.
Correct. So that is what exactly we have done. Now, Sairam, now let's high level go through 2 minutes before we close. Go through this code. What we did here, we imported the libraries, right, Sairam?
No. I missed all the first 1 hour session. So.
No, you came by this time. Okay. We imported the libraries.
So.
Okay. Here I share this code. We talked about the tuples and arrays, how to pull this. We talked about then vectors, so that you get some idea about the vectors. I gave some background to you. So this is where we started. Is that correct, Hema? What we did here, Hema?
We have taken some.
We got the training data, right?
Yeah.
We got the training data. We got the training data.
Vectors out of the
then we split them and prepared this. We split them and prepared the labels and data. So by passing to dancers. So basically it's a preparation stage. These steps, reading, preparing, you will do it even for test data also. Okay. So then this is where you have the data, which is a value. And this data, you will be using it to run the k-means cluster. So for that, Hari, you're right, a k-means object you created from that library. You set some parameters, initial design. So these things, how you pass it as a parameter without hard coding, we can look into that. So then you ran the data that built the model. The model is very helpful to you. Please note that model is based on that input data. Model is based on that input data. The number of clusters, optimum clusters also for that input data.
So that is
Everything is
a bit of the thing, but I'll take it offline with you. I don't want to delay.
Awesome.
Yeah.
No. That is correct. Then we find the how many clusters are there, etc. Then these are only we did some how many clusters, which point went to which. This is just to look into model. Then what you did is a little bit heavy lifting these functions, helper functions, how to calculate the distances. This is where little bit we spend time. This is to find the distance to centroid. This is for a clustering score functions. These functions we are building separately. Hema, I think you will appreciate, you came from Java background, even Java 8, they are using these lambdas. Where you can build a standalone function. These functions can be passed throughout your program. That's why it's a functional program.
Right.
So found the maximum threshold for that data using the distance centroid, found the maximum. Then we used it on the test data. For the test data also I need to prepare. I need to split. I need to do it exactly the first steps. Then this is what we used. We found the maximum threshold for that anomaly. We took that data, it's for test data, and the distance centroid is maximum threshold. We printed the anomaly. Oh, okay. Now we used this one, clustering score. Based on that, we fixed the K. Now imagine, see how a machine learning model. If we know the K, we have the input data, we tested on the test data, and we feel that we are fairly, I think our machine learning clustering model is fairly good with the given data. Then yeah, you apply it on the new data. Every day it is coming. Every day in the evening, you get some 10,000 or 50,000 or 1 million transactions or 10 million transactions. You run this model on those 10 million transactions and see what could be the credit card transactions you want to deny. You may run it in the batch. Okay, that is number one. No, you want to run this on the real-time system. You apply these models on the streaming system. When the data is flowing, you apply. How to apply all those things, we will be learning in the coming classes. But just to summarize, let's focus on these methodologies only. Everything remains the same for whatever the machine learning models you need to get data, prepare data, train the model, and test the data. You need to improve.
Srini, just one question.
Yeah.
Sorry. Can we have this, the code that you can we have this code in a file so that we can practice?
Yeah. I will be sharing it. I can just explore this source file. Yeah. That's it. I'll share it. I've been sharing it, and this is the beauty. You can publish it. Then I get a URL. Immediately I can share to everyone.
Thank you.
Okay, I'll do that.
Question.
Sorry.
It's not
relevant. Yeah. Any other question?
Current algorithm. Srini, are you able to hear me?
Yeah, please.
So I understand the k-means algorithm. Like k is the number of clusters, and we are calculating the mean distance between the centroid and n number of points. That's good.
Mm-hmm.
But real-time data, how do we map it to these points?
So this model or to this point?
To the points. Like we have like some points, right, where we have some xy coordinates, and we are finding out a centroid for the. So
let's see. That is a different architectural issue, Emma. But I want to touch that. See, well, these models can be saved actually. No, these models, whole models can be saved into some modeling file formats will be there, and people can build a web services around this model. Okay. So when you stream it, you can call those models. Actually, we did. I should not name client name. Both of us worked together. Where when we pass this data, we want to check the fraud check. When we call that, there are some rules engines, but at the same time, we also call these models built by someone. They will build a web service around this model. Okay. We call in the real time. Okay. Those are architectural. I'll help you to understand of our team. We will figure it out. Is that okay?
Yeah. Fine.
Yeah. Okay, guys. How does it sound? I know it's overwhelming. Even I have other agenda also. I couldn't do it. It stretched beyond my thoughts. But I really appreciate for staying, listening so many things. But they will settle down slowly. Sir, how does it sound? I know it takes another review needed. After that, you'll be definitely comfortable. If not, we'll make another review also here and there. But how does this sound overall? Oh, approach. Okay. Now you really understood, how these machine learning projects are built at this, the central model. After that, how you deploy it, etc. There is DevOps things will be there. What are your comments, Tyra?
Well, I understand the concepts of it, and like you said, it may need one or two more reviews of it.
But that is correct. But did you get the sense of how these?
Yes, I understand it. Yeah.
Excellent. DK, any comments? How does it sound? Let me put Nagesh. How does it sound?
Yeah, this is interesting actually. I have a lot of questions, but I'll ask you offline. I don't want to take your time here.
No, definitely. This is the only beginning. Everyone, please understand. This is the only beginning.
Okay.
We'll be applying ideas for the classification. This one and some other teams will be representing this. It's only a beginning. It is not the whole thing. You become expert, but get the feel sense of it. How the machine learning projects will be done. So how the machine learning is done at least. Okay.
Yeah, this is a good beginning. Thank you.
Excellent. Okay, I put mute everyone. I'll ask some question. Harish Bokre, how does it sound? Emma, any comment? Kishore, Mukesh, you're on mute.
Okay. Srini, I had just one quick question, Kishore here.
Please.
Srini, when you started this machine learning, okay, you said that, okay, from where, what's the source? Okay, the source is something like from the serving layer, okay, Elasticsearch or Cassandra, okay. From the serving layer, we will like pick up these things and apply our machine learning techniques on that. Okay, so once you get these anomalies, once you apply these models and all, okay, so you get some kind of a like inference of it, right? So from here, if you want to prepare any graphs, charts, or something like kind of a reporting, and also is that this data will be extended, this machine learning data will be like utilized further, or
Yeah, absolutely. The software is so much developed now. Everything is services, pipeline, integrations, etc. The softwares are so much developed. So it is a established software methodology. Okay, how to push this data for reports, or how you want to view this as efficient or not. Those are all rings and bezels. Bells and whistles. Okay? Which there is no intelligence in it. It's already established last 30, 20 years. Kishore.
Okay.
But people can do magic on that. That is very simple. You go to Amazon Web Services. The services that are available through browser you can do. You can just say I want 10 Unix machines together. In one click they will give you. Earlier you have to take a hardware, you have to install Unix, you have to test it, then a lot of things, right?
Correct. Yeah.
So you will be, I tell you, you'll be 100 times get surprised if you come to know what are available. So absolute level. Answer to your question is absolute level.
Yeah. Thanks, Srini. It's a good start. Yeah.
Srini, I have a question.
Yeah, please.
This is Mukesh. Srini, my question is, I thought machine learning is more scientific. Here you're showing all pointers. So is this more related to machine learning with respect to a particular model, or is this everything? Will we have multiple, like this is a clustering, right? Will we have some other things, or?
Yeah, machine learning is a methodology, first to understand. So this machine learning, the model, based on the problems, your models will change, Mukesh. If you are, here you are trying to solve this type of problems in the industry. If you
Sorry,
are solving...
somebody who's not talking can mute because a lot of disturbance.
I put someone on mute. Okay, Mukesh, you also might be on mute. So This is the network security. This type of problem falls into anomaly detection. But suppose you have a website, you want to recommend some products to the customer when they are buying, just like Amazon. Then you'll be using a different algorithm, different library. That is called a recommendation problem. So in a broad sense, 60 to 80% of general enterprise problems of machine learning falls into these four categories. So this is the discussion. What we did is, approach is the same for everything, but this is the algorithm we discussed. Even in clustering, there are some advanced algorithms, but don't worry, start somewhere. This is the problem, clustering problem. This is the recommendation model. This is classification. Like that, Mukesh, answer to your question is four type of problems, solve many use cases, 60 to 80% of enterprise use cases of the machine learning, not deep learning I'm talking about.
So the mathematics part of it will fall in among this four or limited set.
The math, I mean, answer to the question is, did we do any math today? Yes or no?
Yes, we did.
Actually, I can say we haven't done.
Okay.
Because we just to calculate distances only.
Right,
calculate distance, that function is a lot of other things. The real iteration doing a k-means algorithm is already coded in the library. It's heavy lifted in the library. That is where the people from Stanford, people from Google, they build those libraries, Amazon. That is where all the deep mathematics is involved. So people from PhD in machine learning, those people write those libraries. We are taking those libraries and applying them. And here and then we are using a mathematical logic, scientific logic, which we already know and long back. We are just sharpening our brain. We are recalling them. Does it answer your question, Mukesh? Mukesh, you are on mute.
Yeah, Srini, I unmuted. So you mean to say we will have these models which are available by some of the scientists or everyone, and we will be calling them. So everything, what the whole logic, the mathematical logic is inside there, and the calling part is what we are going to take care.
That is correct. Actually, now we don't call it as PhDs, etc. It's a company, because everything is standardized into 4 to 5 libraries. That's it. Amazon gives you libraries, or Microsoft gives you libraries, Google gives you libraries. We are using Apache Spark library. So Amazon uses, but if it is Amazon Cloud, if you are not using Amazon Cloud, you can't use Amazon machine learning library. So this is a general purpose library. Apache Spark is used in all the enterprise for the machine learning. If you're using a deep learning, you may go for Google TensorFlow library. So some people use even TensorFlow itself for machine learning also. It's just a matter of decisions they will take. But the approach and the methodology remains the same. So, but if you use this, most of the clients are using for big data, Apache Spark, and large-scale machine learning is Apache Spark MLLIB. Some people, for some research where there's no too big data, they may be using some other library. But the approach is the same, Mukesh. But our target is enterprises, Fortune 5,000, 500,000. Okay, does it help?
Yes. Thank you.
Oh, great. Who else? Narayana, Nagesh?
I have one question.
Sir. Yeah.
Narayana. What is the test data? What is the difference between test data and trained data?
See, everything is data. Trained data is used to create the model. So the test data is, to see. Sometimes test data you already know. So some people say that this is already outlier. So you are applying the model to find if it is outlier or not. Suppose you have test data which you already know there are 10 outliers in the test data. Suppose you already know. When you apply the model, how many of those 10 your model is able to find out as an outlier? So out of those 10 outliers in the test data, this is historic data, which they know, hey, in the last 1 year, we got 100 times people try to hack. So those 100 transactions are collected. Those 100 transactions, suppose you apply as a test data. So out of those 100, your system found only 60 as outliers. It means your system is 60% efficient. So we will focus on how to improve it. So it is a training data used for model. Test data is to see how effective is your model, etc. But we will be talking in the coming days. Don't worry. This is not specifically applied to this algorithm alone. Approach remains the same.
Yeah,
Okay.
I'm fine. Yeah. Thank you.
Another 2 minutes, guys. I think we spend a lot of time. Siva, Surya, Basavaya, you didn't ask any questions. Raja, Leela, how is it going? I think first time you are attending my class. On first day itself.
There is a lot of background noise. Can you mute people?
Sure. How does it sound? You need not have question, but you can say it's overwhelming, or we'll help you. We'll make you more comfortable. But I have to give you this stuff today.
Yeah, okay, Shini. I have I have Java background, so I'm able to relate. And if I do some, practical sessions, I'll be able to, understand more.
You will surely. You'll surely. But can you see? Can you connect the dots at least?
Yes, I can.
What is happening? That is more important. Writing a few lines, don't worry. Lot of code is available everywhere. Harish, any comments or any questions?
Not for the moment.
Harish, you're on mute. Okay. Kiran, Nagesh, I already talked. Raja, you hear anything?
Yes, Srini, I was able to follow to the most part.
Okay, excellent. Surya and Basavaya from India. Basavaya from India. It's late for you, I think. Okay, no problem.
Srini?
Probably, I think. Yeah.
Srini, what time is the class tomorrow?
Okay, same time.
So
7:30 PST.
So moving forward, it's going to be 7:30 PST now?
Yeah. Any issue? You guys prefer? You see, it's 7:30 or 8. So I thought of for India, it's going to be late, so that's why I moved 30 minutes. Anyway, we'll take it score. You can reach me, text me. I can maximum make it 8, but 7:30 earlier 7:30 PST or 8.
Saturday is not a big issue. Sunday definitely it will help if it's earlier. Yeah, 7:30 would.
Okay, I think I will connect with you on Facebook or personally. Let's keep it offline. Okay, DK, any comments? I think it took a lot of time. Okay, appreciate guys for focusing on this. I'll post the video soon. And tomorrow we'll meet at 7:30. It will be 2.5 hours to 3 maximum. It won't be like this. So this video is a little bit heavy lifting. It's good.
Yeah.
Okay, good job, guys, everyone.
Thank you very much.
Okay. Have a good day.
Thank you.
Have a good day, guys. Bye.
Bye, Basraya. Nagesh.
Thanks, Srini.
Mukesh, Leela, Harun,
Thanks,
Srivas,
Srini.
Raja.
Thank you.
Let's connect. Harun,
Thank
now
you,
you
Srini.
have a lot of responsibility to make them comfortable with this. I know you can do great things. Kishore, Hari, good job, good questions. Keep it up. This will help the team. Narana, good job. Everyone, good job.